Looking up at the night sky, you see stars scattered like diamonds on black velvet, and in that moment of wonder, you might believe you understand the universe's story. You've been told it began 13.8 billion years ago in a moment of explosive creation called the Big Bang. You've heard that space itself expanded faster than light, stretching from a point smaller than an atom to something unimaginably vast. But here's the truth that will shatter everything you think you know. The Big Bang did not bang. There was no explosion. No moment when nothing became everything. No cosmic fireworks lighting up an empty void. The very name we've given to the birth of our universe is a lie, a convenient fiction that makes us feel comfortable with the incomprehensible. What really happened 13.8 billion years ago wasn't a bang at all, but something far more mysterious, far more unsettling, and infinitely more beautiful than any explosion could ever be. You see, we live inside a cosmic paradox so profound that even saying the universe began is meaningless. Time itself had no meaning before time existed. Space had no dimension before space was born. And yet, somehow, from this absence of everything, not darkness, because darkness implies the possibility of light, not emptiness, because emptiness suggests a container. Somehow, from pure nothingness, everything emerged. But not with a bang, with something far stranger. Imagine, if you can, the moment before the first moment. Not 13.8 billion years ago, because years hadn't been invented yet. Not in a place, because place was still a concept waiting to be born. In this non-time, in this non-space, something extraordinary was about to unfold. Not an explosion, but an expansion so smooth, so perfectly orchestrated, that it makes every symphony ever composed sound like chaos. The universe didn't explode into existence. It whispered itself into being. This whisper, this gentle, inexorable expansion, began not from a point, but from everywhere at once. Picture this. Every cubic centimeter of space you can imagine, stretching in all directions as far as thought can travel, began expanding simultaneously. Not expanding into something because there was no something to expand into. The universe wasn't growing inside a cosmic box. The universe was creating the very concept of inside as it grew. Space wasn't being filled. Space itself was being born, one infinitesimally small increment at a time, in a process so perfectly smooth that if you had been there to witness it, you wouldn't have seen an explosion at all. You would have seen the most graceful transformation in the history of existence. Potential becoming reality. Nothingness becoming everything. Silence becoming the first note of cosmic music. But here's where the story becomes truly unsettling. The Big Bang, this moment we've named but never truly understood, might not have been a beginning at all. It might have been a transition, a phase change, a cosmic reboot. What if the universe you're sitting in right now, the one expanding, around you at this very moment, is just the latest iteration in an endless cycle of cosmic death and rebirth? What if 13.8 billion years ago wasn't the start of time, but simply the most recent reset button in a cosmic computer that's been running for eternity? Consider the mathematics of infinity for a moment. If time stretches backwards without end, then everything that can happen must happen. Every possible arrangement of matter and energy, every possible universe, every possible version of you reading these words, all of it must exist somewhere in the vast expanse of eternal time. And if that's true, then this moment, right now, has happened before, will happen again, is happening in countless other universes at this very instant. The Big Bang becomes not a unique event, but a recurring cosmic heartbeat, pumping new universes into existence while others fade away like dying stars. The temperature of the cosmic microwave background radiation, that ancient light still washing over us from the universe's infancy, tells us that space was once incredibly hot and dense. But it doesn't tell us hot and dense compared to what. If the universe began from a singularity, a point of infinite density and infinite temperature, then by definition, temperature and density become meaningless concepts. Infinity plus 1 equals infinity. Infinity divided by infinity equals nothing we can understand. The mathematics break down precisely at the moment when we most need them to work. This is why the story of cosmic creation is so much stranger than any explosion. The universe didn't begin. It transformed from one state of being into another, from a state where the laws of physics as we know them had no meaning, into a state where stars could shine, planets could form, and consciousness could emerge to ponder its own existence. The Big Bang wasn't the universe's birth certificate. It was its metamorphosis. And here's what should keep you awake at night. If the transformation happened once, it could happen again. Right now, at this very moment, space itself might be preparing for another phase change. The dark energy that's, say, accelerating the universe's expansion might not be a constant force driving everything apart forever. It might be the early symptom of another cosmic transition. In a trillion years, in a trillion years, or perhaps in the next instant, the universe might whisper itself into an entirely new form of existence, and everything we call reality would become as meaningless as the state of being that existed before the Big Bang. But let's return to that moment 13.8 billion years ago, when the universe was 1 second old. In that single tick of time, more transformation occurred than in all the billions of years that followed. The four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, were still learning how to be separate entities. They had been unified in the cosmic furnace, indistinguishable from one another, but as space expanded and temperatures dropped, they began to differentiate like instruments in an orchestra, finding their individual voices. First, gravity separated from the others, then the strong nuclear force branched off. Then finally, electromagnetism and the weak nuclear force went their separate ways. The universe was teaching itself how to be a universe. The temperature at this moment was about 10 billion degrees Kelvin. To put this in perspective, the core of our sun burns at 15 million degrees. The surface of the hottest stars reaches about 50,000 degrees. The moment of cosmic nucleosynthesis, when the first atomic nuclei were forged, required temperatures 1,000 times hotter than the sun's core. But at 1 second after the Big Bang, the universe was nearly 1,000,000 times hotter than that. At these temperatures, matter as we know it couldn't exist. Atoms were impossible. Even the protons and neutrons that would later form the hearts of atoms were still being assembled from their component quarks and gluons. in a cosmic kitchen where the ingredients were pure energy, and the cooking method was the fundamental forces, learning how to work together. This is the part of the story that should make you question everything you think you know about reality. Matter, the stuff you're made of, the stuff that makes up the chair you're sitting in, the planet beneath your feet, the stars burning in distant galaxies. Matter is nothing more than energy that's been convinced to hold still for a while. The equation E=mc2 doesn't just mean that mass can be converted to energy. It means that mass is energy, wearing a disguise. Every atom in your body is a tiny knot of space-time that's been tied so tightly it forgot how to be pure energy. You are not made of matter. You are made of crystallized light, frozen into patterns complex enough to think, to feel, to wonder about your own existence. In the first 3 minutes after the Big Bang, the universe accomplished something that would never be possible again. It built the atomic nuclei of hydrogen, helium, and lithium from scratch, not by assembling them piece by piece in the heart of a star. Stars hadn't been invented yet, but by creating the precise conditions where protons and neutrons would stick together in exactly the right ratios to form the first atomic nuclei. This cosmic alchemy required a perfect balance of temperature, density, and timing that lasted only about 17 minutes. Too hot, and the nuclei would be blown apart as quickly as they formed. Too cool, and the particles wouldn't have enough energy to overcome their mutual repulsion and fuse together. The universe had to thread a needle in four-dimensional space-time, and it did so with a precision that makes Swiss watchmakers look clumsy. But here's what should really disturb your sleep. The universe got the recipe exactly right on the first try. There was no practice run, no cosmic rehearsal, no opportunity to make adjustments. The fundamental constants of nature, the strength of gravity, the charge of the electron, the mass of the proton, all had to be precisely calibrated to create a universe where complex structure could emerge. Change any one of these constants by even a tiny fraction, and you get a universe where atoms can't form, where stars can't shine, where planets can't exist, where life becomes impossible. The margin of error for a life-supporting universe is so small that it defies probability. It's as if the universe knew what it wanted to become before it began becoming it. This brings us to one of the most haunting questions in all of cosmology. Why is there something rather than nothing? The default state of existence should be non-existence. Zero energy, zero matter, zero space, zero time. Perfect, eternal nothingness. And yet, here you are, reading these words, made of atoms that were forged in the first few minutes of cosmic time, sustained by energy that's been flowing through space for nearly 14 billion years. Your existence is not just improbable, it's impossible according to everything we understand about the fundamental nature of reality. And yet you exist anyway, thinking thoughts that are themselves patterns of energy moving through neural networks that evolved over billions of years from cosmic dust. The cosmic microwave background radiation, that ancient afterglow still detectable in every direction we look, carries within it the seeds of everything that would ever exist. Tiny fluctuations in temperature, variations so small they were almost perfectly smooth, became the gravity wells that would eventually collapse into the first stars, the first galaxies, the first planetary systems where life could take hold. and begin the long journey toward consciousness. If space had been perfectly smooth in those early moments, gravity would have had nothing to grab hold of, nothing to pull together, and the universe would have remained a thin, cold soup of particles, expanding forever into darkness. If the fluctuations had been even slightly larger, matter would have collapsed into black holes before stars could form, and the universe would have become a collection of gravitational monsters feeding on darkness. But the fluctuations were exactly the right size, distributed in exactly the right pattern, to create a universe where you could evolve over billions of years and then look back at the cosmic microwave background and see your own origin story written in ancient light. This is perhaps the most profound recursive loop in all of existence. The universe created conscious beings who could turn around and observe the universe's infancy, making the cosmos aware of itself through the eyes and instruments of creatures, made from its own stellar dust. Now, let's confront the most disturbing implication of cosmic expansion. The universe isn't just getting bigger, it's accelerating. Space itself is stretching faster and faster, driven by something we call dark energy, that makes up nearly 70% of everything that exists, yet we have no idea what it is. This acceleration means that galaxies are moving away from us at ever-increasing speeds. Eventually, they'll be moving so fast that their light will never reach us. The observable universe, everything we can see, everything we can ever hope to see, is shrinking even as the actual universe grows larger. We are becoming cosmically isolated, cut off from more and more of reality with each passing moment. In 100 billion years, anyone living in our galaxy will look out at the night sky and see nothing. No distant galaxies, no cosmic microwave background, no evidence that there was ever a Big Bang at all. They'll inhabit what appears to be a universe consisting only of the Milky Way, surrounded by infinite empty darkness. And if they're astronomers trying to understand their cosmos, they'll conclude that the universe is static, eternal, and consists of one galaxy floating in an endless void. They'll be wrong, but they'll have no way of knowing they're wrong, because all the evidence for cosmic expansion will have literally moved beyond their ability to observe it. This means we are living in a special time, perhaps the only time in cosmic history when it's possible to see the universe as it really is. We exist in a narrow window between the era when the cosmos was too young and chaotic to support complex observers, and the far future era when the cosmos will have expanded so much that its history becomes invisible. If consciousness had emerged 100 billion years later, it would never discover the Big Bang, never realize that the universe had a beginning, never understand that space itself is expanding. We are the universe's first and possibly only chance to understand its own story. But even our privileged position in cosmic history doesn't give us the full picture. The observable universe, everything we can see even with our most powerful telescopes, extends only about 46 billion light-years in every direction. This might seem contradictory since the universe is only 13.8 billion years old. But remember that space itself has been expanding during the entire time that light has been traveling toward us from distant objects. The most distant galaxies we can observe are now much farther away than they were when they emitted the light we're seeing today. We're looking at their past selves, frozen in ancient light that's been stretched and reddened by the expansion of space itself. Beyond our observable horizon lies the unobservable universe, regions of space that are so far away their light hasn't had time to reach us yet, or never will reach us because of accelerating expansion. This unobservable universe might be infinite in size, containing infinite galaxies, infinite stars, infinite planets, and perhaps infinite civilizations asking the same questions we're asking right now. Or it might be finite, but unimaginably vast, curved back on itself like the surface of a sphere so large that it appears flat from our perspective. The truth is, we have no way of knowing, and we may never have a way of knowing, whether the universe beyond our cosmic horizon is finite or infinite, whether it continues forever or eventually loops back on itself, whether it's filled with matter and energy like the region we can observe, or whether it's empty, dark, and cold. This ignorance isn't a failure of our science or our instruments. It's a fundamental limitation imposed by the structure of space-time itself. Information can't travel faster than light, so there will always be regions of the universe from which no information can ever reach us. We are trapped inside our cosmic bubble, able to see only a tiny fraction of what exists, forced to make educated guesses about the nature of reality based on a sample size that might be infinitesimally small compared to the whole. We are cosmic islanders, surrounded by an ocean so vast that we can't even see to its horizon, trying to understand the nature of water by studying the droplets on our shore. And here's the final, most unsettling thought. Even our cosmic island is temporary. The dark energy driving cosmic acceleration isn't just stretching space, it's accelerating the stretching. This means that expansion will become faster and faster until eventually it becomes so rapid that space itself begins to rip apart at the most fundamental level. First, galaxies will become isolated islands in an increasingly empty void. Then star formation will cease as galaxies exhaust their supply of gas and dust. The stars that exist will burn out one by one, starting with the massive ones that live fast and die young, ending with the tiny red dwarf stars that burn so slowly they could continue shining for trillions of years. But even the longest-lived stars will eventually exhaust their fuel and fade to black. In the far future, when the last star has died and the universe has grown cold and dark, protons themselves might begin to decay, dissolving the atomic nuclei that have been stable for billions of years. Even black holes, those seemingly eternal gravitational monsters, will eventually evaporate through Hawking radiation, taking trillions upon trillions of years to slowly fade away into nothingness. And in the end, if current theories are correct, the universe will become a thin, cold soup of elementary particles and radiation, expanding forever into darkness, with no possibility of structure, no possibility of complexity, no possibility of consciousness ever emerging again. This is the heat death of the universe. Not a fiery catastrophe, but a slow fade to black. A gradual running down of cosmic energy until nothing interesting can ever happen again. It's the ultimate victory of entropy over order, of chaos over complexity, of darkness over light. And yet, paradoxically, this inevitable ending makes the current moment infinitely precious. We exist during the brief cosmic instant when the universe is complex enough to support life, consciousness, and the capacity to wonder about our own existence. We are the universe's way of knowing itself, even as it races toward its own dissolution. The Big Bang wasn't a bang. It was the whispered beginning of the most extraordinary story ever told. A story of energy becoming matter, matter becoming stars, stars becoming the heavy elements necessary for planets and life, life becoming consciousness, and consciousness becoming the universe's way of contemplating its own existence. We are not separate from this cosmic story. We are the story. Every atom in your body was forged in the nuclear furnace of a dying star. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was manufactured in stellar cores and scattered across space when those stars exhausted their fuel and exploded as supernovae. You are not just in the universe. You are the universe, organized into a pattern complex enough to look back at itself and wonder how it all began. And that wondering, that capacity for cosmic contemplation, might be the most extraordinary thing that has ever happened in the history of space-time. For nearly 14 billion years, the universe existed without knowing it existed. Matter clumped together under gravity's patient pull. Stars ignited their nuclear fires. Planets formed and cooled. Chemical reactions grew more and more complex, but there was no consciousness to witness any of it. No intelligence to ask questions about what it all meant. Then, somewhere in the cosmic dark, life began. Somehow, arrangements of matter became so complex that they began to process information, to respond to their environment, to reproduce and evolve, and eventually to think. The universe had awakened to itself. This awakening might be incredibly rare. In all the billions of galaxies we can observe, each containing hundreds of billions of stars, each star potentially surrounded by planets, we have found no definitive evidence of other conscious beings asking the same questions we're asking. We might be alone, the only conscious observers in a cosmos so vast it defies imagination. Or we might be one of countless civilizations scattered across space and time, each struggling to understand their place in the cosmic story. Either possibility is profound beyond words. If we're alone, then consciousness is the rarest and most precious thing in existence, making every human thought and feeling infinitely valuable. If we're not alone, then the universe has awakened to itself in countless different ways, experiencing its own existence through billions of different perspectives, each one adding to the cosmos's understanding of itself. The mystery deepens when we consider that our awakening might not be accidental. The laws of physics seem almost designed to produce complexity. The fundamental constants are tuned with such precision that tiny changes would make stars, planets, atoms, or molecules impossible. Some scientists suggest we live in a multiverse, an infinite collection of universes with different physical laws, and we exist in one of the rare universes where the laws happen to allow for complexity and consciousness. Others propose that consciousness itself plays a fundamental role in shaping reality, that the act of observation somehow participates in determining what becomes real. These ideas push us to the very edge of what science can explore, where physics meets philosophy and the hard questions about existence become unavoidable. But perhaps the most profound implication of our cosmic story is this: if consciousness is the universe's way of knowing itself, then every moment of awareness is a cosmic event. When you look up at the night sky and feel that sense of wonder, You're not just a human having a spiritual experience. You're the cosmos contemplating its own vastness. When you ponder the mystery of existence, you're the universe questioning its own nature. When you feel awe at the beauty and complexity of the world around you, you're space-time itself marveling at the patterns it has created. Your consciousness is not separate from the cosmic story. It is the current chapter in that story. The latest development in the universe's long journey from simple energy to complex awareness. This understanding transforms everything. It means that your life, brief as it is on cosmic timescales, plays an essential role in the universe's ongoing project of self-discovery. Every question you ask, every moment of wonder you experience, every connection you make with another conscious being adds to the cosmos's understanding of itself. You are not a cosmic accident or an insignificant speck in an indifferent universe. You are the universe's way of experiencing wonder, love, curiosity, and the profound mystery of existence itself. Through your eyes, the cosmos sees its own beauty. Through your mind, it contemplates its own nature. Through your capacity for emotion, it feels the full weight and wonder of its own existence. The Big Bang didn't bang. It whispered the universe into existence with such perfect precision that 13.8 billion years later, consciousness could emerge to look back at that moment and recognize it as the beginning of everything we know and everything we are. And in that recognition, the cosmos completes a circle that began with the first expansion of space and time and continues with every moment of awareness, every flash of understanding, every sense of wonder at the magnificent, mysterious, impossible fact that something exists rather than nothing, and that we are here to witness it all. The story we've been told about cosmic creation begins with numbers that sound precise, scientific, absolute. The universe is 13.8 billion years old. It contains roughly 2 trillion galaxies. Its diameter spans 93 billion light-years. These figures roll off the tongues of astronomers and physicists with the confidence of merchants counting coins, as TTs ye, if we've somehow managed to measure infinity and weigh eternity on cosmic scales. But here's what they don't tell you in the textbooks. These numbers are built on assumptions so profound, so untested, and so potentially wrong that they might be nothing more than elaborate mathematical poetry, masquerading as scientific fact. Consider the cosmic microwave background radiation, that faint whisper of ancient light that fills every cubic centimeter of space around you right now. Scientists call it the afterglow of the Big Bang, the smoking gun that proves the universe began in a hot, dense state 13.8 billion years ago. They've measured its temperature to incredible precision, 2.725 Kelvin above absolute zero, with tiny fluctuations that map out the seeds of every galaxy that would ever form. NASA has spent billions of dollars building satellites to study this radiation, creating temperature maps so detailed they can show you variations smaller than a millionth of a degree. It's considered the most perfect evidence we have for the Big Bang theory, as solid as the ground beneath your feet. But what if this cosmic microwave background isn't the afterglow of creation at all? What if it's something else entirely? The echo of a cosmic phase transition we don't understand, the shadow cast by dimensions we can't perceive, or the background hum of processes so alien to our experience that we've mistaken them for the birth cry of the universe itself? The radiation is real. The measurements are accurate, but our interpretation of what it means rests on theoretical foundations that would make a house of cards look stable by comparison. The early universe, we're told, was a furnace where temperatures reached trillions of degrees and densities crushed matter into states that have never existed since. In this cosmic crucible, time itself was still learning how to flow properly. Space was expanding so rapidly that particles could be separated by vast distances in less time than it takes light to travel between them. The four fundamental forces were unified into a single superforce that governed reality according to rules we can barely imagine. It sounds like science fiction, and perhaps it is. Perhaps we've constructed an elaborate mythology around a few temperature measurements and redshift observations, building castles of theory on foundations of sand. Here's the uncomfortable truth that keeps cosmologists awake at night. We can see less than 5% of the universe. The rest, 95% of everything that exists, is composed of dark matter and dark energy, substances so mysterious that calling them dark is really just an admission that we have no idea what they are. Dark matter supposedly makes up 27% of the cosmos, providing the gravitational scaffolding around which galaxies form and cluster. But despite decades of searching with the most sensitive detectors ever built, we've never found a single particle of the stuff. It's invisible, intangible, and interacts with ordinary matter only through gravity. For all we know, it doesn't exist at all. And the gravitational effects we attribute to dark matter are caused by something far stranger. Extra dimensions bleeding through into our reality. Modifications to gravity we haven't discovered yet. Or the influence of parallel universes pressing against our own. Dark energy is even more mysterious. It supposedly makes up 68% of the universe, driving the accelerating expansion of space itself. But we have no idea what it is, where it comes from, or why it exists. The best candidates for dark energy, from quantum field theory, predict values that are wrong by a factor of 10 to 20, a number so large that if you wrote it out in decimal notation, the zeros would stretch across the observable universe and back again several billion times. This isn't just a small error in our calculations. This is physics failing so spectacularly that it suggests we don't understand something fundamental about the nature of reality itself. And yet, based on these mysterious substances that might not even exist, we've concluded that the universe is 13.8 billion years old and 93 billion light-years across. We've mapped its history from the first fraction of a second after the Big Bang to the present day. We've calculated how many atoms it contains, predicted its future evolution, and declared ourselves masters of cosmic time and space. But strip away the dark matter and dark energy, admit that we don't know what 95% of the universe is made of, and our confident timeline of cosmic evolution becomes a story told by someone who can only see the shadows on the cave wall, trying to describe the fire. The cosmic microwave background itself presents a puzzle that should shake your faith in everything we think we know about the universe's beginning. This radiation appears almost perfectly uniform in every direction we look. The same temperature, the same intensity, the same spectrum of light, whether we point our telescopes toward the constellation Draco or the Southern Cross. This uniformity suggests that the early universe was in thermal equilibrium, like a cup of coffee that's been sitting long enough for every molecule to reach the same temperature. But here's the problem. Light can only travel at the speed of light. And in the 380,000 years between the Big Bang and the moment when the cosmic microwave background was released, light could only travel about 380,000 light-years, a tiny fraction of the size the universe had already grown to by that time. This means that regions of the early universe that are now separated by billions of light-years were never in contact with each other during the epoch when the cosmic microwave background formed. They had no way to exchange energy, no mechanism to reach thermal equilibrium, no reason to be at exactly the same temperature. And yet they are. The cosmic microwave background is uniform to within 1 part in 100,000 across the entire sky, as if the universe somehow coordinated its temperature across vast regions that had never communicated with each other. It's like walking into a library and finding that every book has exactly 347 pages, even though the authors never met each other and wrote their books on different continents across different centuries. The standard solution to this horizon problem is cosmic inflation, the idea that space itself expanded exponentially during the first tiny fraction of a second after the Big Bang, stretching a small, causally connected region to enormous size and smoothing out any initial irregularities. In less than 10 monos to 32 seconds, the theory goes, the universe grew by a factor of at least 10 to 26, turning a region smaller than a proton into something larger than a grapefruit, all while maintaining perfect smoothness and uniformity. This inflation supposedly ended as suddenly as it began, transitioning into the much slower expansion we observe today. Cosmic inflation solves the horizon problem elegantly, but it creates new mysteries that are perhaps even more troubling. If inflation could begin spontaneously from quantum fluctuations in space-time, then it should still be happening now, constantly creating new bubble universes that expand exponentially before settling into slower expansion like our own. This eternal inflation scenario suggests that our observable universe is just one bubble in an infinite foam of bubble universes, each with potentially different physical laws, different fundamental constants, different possibilities for structure and complexity. Most of these universes would be sterile and empty, unable to support stars, planets, or life. We exist in one of the rare bubbles where the laws of physics happen to allow for complexity, not because the laws were designed for life, but because we can only exist in universes where such complexity is possible. But eternal inflation raises a devastating question. If new universes are constantly being created, each with its own version of physical laws, then what determines which laws we observe? In an infinite multiverse, every possible universe exists somewhere, including universes where the laws of physics change from moment to moment, where mathematics works differently, where consciousness operates according to completely alien principles. How do we know that our universe is governed by consistent laws at all? Perhaps the regularities we observe, the speed of light, the strength of gravity, the charge of the electron, are just temporary patterns in a cosmos where anything and everything is possible, and we exist during a brief moment when the laws happen to be stable enough to support observers. This multiverse hypothesis makes testable predictions impossible. If every conceivable universe exists somewhere in the infinite foam of cosmic inflation, then any observation we make is compatible with the theory, because there must be universes where that observation would be made by conscious beings pondering their existence. The theory becomes unfalsifiable, more philosophy than science, and we're left wondering whether we're studying the universe or constructing elaborate mathematical theology. Even without the multiverse complications, the precision required for our universe to support complexity is staggering. The ratio of the electromagnetic force to the gravitational force is approximately 10 to 36. If this ratio were significantly different, if gravity were much stronger relative to electromagnetism, stars would collapse under their own weight before nuclear fusion could begin, and the universe would be filled with black holes instead of shining suns. If gravity were much weaker, matter would never clump together enough to form stars at all, and space would remain a thin, cold soup of particles expanding forever into darkness. The mass difference between protons and neutrons is about 0.14% of the proton's mass. This tiny difference is what makes hydrogen stable and allows nuclear fusion in stars to convert hydrogen into helium, releasing the energy that powers stellar evolution. If neutrons were just slightly lighter, they would decay inside atomic nuclei, making atoms heavier than hydrogen impossible. If they were slightly heavier, protons would capture electrons and become neutrons, eliminating the positive charges that hold atoms together. The margin of error for a universe that can build complex structures is vanishingly small, as if reality were balanced on a knife's edge between chaos and emptiness. The expansion rate of the universe itself had to be precisely calibrated. 2. Fast, and matter would never have time to clump together under gravity before being stretched too thin by cosmic expansion. Too slow, and the universe would have collapsed back on itself in a big crunch before stars could form and evolve. The TD critical density, the exact amount of matter and energy required for flat spacetime, is approximately 6 protons per cubic meter of space. Our universe appears to have exactly this critical density, within the margins of observational error. This flatness is maintained by the mysterious dark energy that accelerates cosmic expansion at exactly the right rate to keep space-time geometry perfectly balanced between curvature and emptiness. But here's where the numbers become truly unsettling. The vacuum energy of empty space, the energy inherent in the quantum fields that fill every point in the universe, should, according to our best theories, have a density $120 times larger than the critical density. This vacuum energy should curve space-time so severely that the universe would collapse into a black hole in less than a Planck time, about 10 to 43 seconds. The fact that space is nearly flat instead suggests either that our theories are catastrophically wrong, or that there's some mechanism canceling out the vacuum energy with impossible precision, leaving behind just enough dark energy to drive. Cosmic acceleration. This cosmological constant problem is perhaps the most embarrassing failure in theoretical physics. It's not just that we don't understand dark energy, it's that our understanding of quantum mechanics and general relativity, when combined, predicts a universe that couldn't exist for even the briefest instant. Either we're missing something fundamental about the nature of space, time, matter, and energy, or we're living in a cosmos that operates according to principles so alien to our current physics that everything we think we know about reality is provisional at best. The cosmic web itself, the largest structure in the universe, presents patterns that challenge our understanding of how complexity emerges from simplicity. Galaxies aren't randomly scattered through space. They're organized into an intricate network of filaments, walls, and voids that looks remarkably like the neural networks in a human brain, or the mycelial networks that connect forest ecosystems. Dark matter supposedly provides the gravitational scaffolding for this cosmic web, but the detailed structure we observe required initial density fluctuations that were neither perfectly smooth nor completely random. They had to have exactly the right statistical properties to grow under gravity into the magnificent architecture of the large-scale universe. These primordial fluctuations are preserved in the cosmic microwave background as tiny temperature variations, hot and cold spots that mark the locations where matter was slightly more or less dense in the early universe. The pattern of these fluctuations contains what cosmologists call the baryon acoustic oscillations, a series of peaks in the temperature distribution that supposedly represent sound waves propagating through the hot plasma of the early universe. But sound waves require a medium to travel through, and in the first 380,000 years after the Big Bang, the universe was supposedly so hot and dense that photons and matter were locked together in a cosmic soup where the very concept of sound becomes questionable. Moreover, the scale of these acoustic oscillations, about 150 megaparsecs in today's universe, depends critically on the speed of sound in the primordial plasma, which in turn depends on the density of ordinary matter relative to radiation. The fact that we observe these oscillations at all, and that they have exactly the right amplitude and spacing to match theoretical predictions, requires a precise balance between matter and radiation that had to be established in the first few minutes after the Big Bang, when the universe was undergoing nuclear fusion and creating the light elements from which everything else would eventually be built. But perhaps the most profound mystery hidden in the cosmic microwave background is what it doesn't show us. The universe appears to have no memory of what came before inflation, no information about the initial conditions that led to the Big Bang, no trace of the cosmic state that preceded our current epoch of expansion. Inflation supposedly erased all evidence of earlier cosmological evolution, stretching any pre-existing structures to scales so large that they're beyond our observational horizon. It's as if the universe underwent cosmic amnesia, forgetting its own origin story and leaving us to reconstruct its history from the faintest of clues. This erasure of initial conditions is both elegant and troubling. It means that cosmic inflation could have begun from almost any conceivable starting point. A quantum fluctuation, a phase transition, the collision of higher dimensional objects, the decay of a previous universe, and still produced the smooth, flat cosmos we observe today. But it also means that certain questions about cosmic origins might be fundamentally unanswerable. If inflation erased all information about what came before, then asking what caused the Big Bang might be like asking what's north of the North Pole. A question that seems meaningful but dissolves under scrutiny. The age of the universe itself, that confident figure of 13.28 billion years, rests on measurements of the cosmic expansion rate, the abundance of light elements, and the temperature fluctuations in the cosmic microwave background. But each of these observations requires us to assume that the laws of physics have remained constant throughout cosmic history, that the speed of light hasn't changed, that the strength of gravity has remained stable, that the fundamental constants we measure in laboratories today are the same constants that governed nuclear fusion in the first few minutes after the Big Bang. Recent observations suggest that some of these assumptions might be wrong. The fine structure constant, a number that determines the strength of electromagnetic interactions, appears to have been slightly different in the early universe based on spectroscopic observations of distant quasars. If fundamental constants can change over cosmic time, then all our calculations of cosmic age, size, and evolution need to be reconsidered. We might be living in a universe where the laws of physics themselves evolve, where the constants of nature drift slowly across billions of years, where the universe of today operates according to slightly different rules than the universe of yesterday. This possibility transforms cosmology from a science of definitive answers into a discipline of educated speculation. If we can't trust that nature's laws remain constant, then extrapolating backwards from present observations to reconstruct cosmic history becomes an exercise in building elaborate scenarios on shifting theoretical foundations. The precision of our measurements becomes irrelevant if the phenomena we're measuring are governed by evolving physical principles that we don't understand. Even more unsettling is the realization that our location in space and time might be fundamentally special. We observe the universe during the brief cosmic epoch when stars are shining, galaxies are forming, and complexity is possible. In the far future, when stellar evolution has run its course and cosmic expansion has isolated galaxy clusters from each other, the night sky will be dark and empty, containing no evidence of the Big Bang, no cosmic microwave background, no distant galaxies to reveal the universe's expansion. Future cosmologists will inherit a cosmos that appears static, eternal, and consisting of one lonely galaxy surrounded by infinite darkness. But our temporal location might be special in more subtle ways. We exist during the era when the cosmic microwave background is still detectable, when the light elements created in Big Bang nucleosynthesis haven't been completely processed by stellar evolution, when the expansion of space is accelerating, but hasn't yet begun to tear apart the fundamental structure of matter itself. We observe the universe during a narrow window of cosmic history, when evidence for its hot, dense beginning is still preserved, when the fossil radiation of creation is still warm enough to measure, when the expansion rate is still slow enough that we can see deep into cosmic history. This temporal coincidence is either extraordinarily lucky or profoundly significant. Either consciousness happened to emerge during the only epoch when the universe's origin story remains visible, or there's something about the conditions that allow for cosmic observability that also allows for the emergence of observers. Perhaps universes naturally evolve toward states where complexity and consciousness become possible, and the ability to understand cosmic history is somehow connected to the physical conditions that make intelligence possible in the first place. The cosmic microwave background carries within it the seeds of this mystery. Those tiny temperature fluctuations, variations of just a few microkelvin in a background temperature of 2.7 Kelvin, contained all the information necessary to build galaxies, stars, planets, and eventually conscious beings capable of observing them. The universe somehow encrypted its own future evolution in the pattern of thermal fluctuations left over from its infancy, like a cosmic DNA carrying the genetic code for everything that would ever exist. But if the fluctuations had been slightly different, if some cosmic butterfly had flapped its wings in the primordial plasma, you wouldn't exist to read these words. The galaxy containing our solar system might never have formed, or it might have collapsed into a massive black hole before star formation could begin. The tiny overdensity that would eventually become the local group of galaxies might have been smoothed out by cosmic expansion, leaving this region of space empty and dark for all eternity. Your existence depends on the precise amplitude and phase of sound waves that propagated through the universe when it was less than 400,000 years old, and the margin of error for a cosmos capable of producing observers is vanishingly small. This suggests that consciousness and cosmic observability might be more deeply connected than we've dared to imagine. Perhaps the universe's apparent fine-tuning for complexity isn't a coincidence or the result of divine intervention, but a consequence of something more subtle, a selection effect where only universes capable of producing observers can be observed, or a feedback loop where the act of observation somehow participates in determining what becomes real. If consciousness plays a fundamental role in the cosmic story, then asking how big and old the universe is becomes a question not just about space and time, but about the nature of awareness itself and its relationship to the reality it observes. 18. Numbers we've assigned to cosmic scale and duration, 13.8 billion years, 93 billion light-years, 2 trillion galaxies, might be less like measurements of objective reality and more like symptoms of the particular kind of universe that allows for measurement in the first place. We exist in a cosmos that's old enough for complexity to emerge, large enough for diversity to flourish, and structured enough for consciousness to evolve and turn its attention toward understanding its own cosmic context. Whether these properties are accidental, inevitable, or somehow related to the deeper mysteries of observation and existence remains one of the most profound questions we can ask about the nature of reality itself. Picture reality as a vast library where every book that could ever be written already exists somewhere on the infinite shelves. Past, present, and future are not flowing like a river, but arranged like volumes in this cosmic collection, each moment as real and permanent as the others. You are not moving through time. You are simply reading different pages of your own story, believing in the illusion of sequential narrative, while every chapter of your existence sits motionless on the shelf of space-time. This is the block universe theory, and if it's correct, then everything you think you know about the nature of time, causation, and free will is nothing more than a persistent delusion created by the particular way consciousness processes information. Einstein glimpsed this truth when he realized that simultaneity is relative, that there is no universal now that applies everywhere in the universe. Two events that appear simultaneous to one observer will occur at different times for another observer moving at high speed relative to the first. This relativity of simultaneity implies that the future already exists in some reference frame, even as you experience it as uncertain and undetermined. When Einstein's friend Michele Besso died, Einstein wrote to console Besso's family. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. He wasn't offering empty comfort. He was describing what he believed to be the fundamental structure of reality itself. But if the future already exists, written into the geometry of space-time like destinations on a map, then what happened to the moment of cosmic creation we call the Big Bang? In a block universe, there is no before the Big Bang and no after it. Only the complete four-dimensional structure of space-time laid out like a landscape that has always existed and will always exist. The Big Bang becomes not a moment when time began, but a boundary condition, a place where the geometry of space-time becomes so curved that our ordinary concepts of causation and temporal sequence break down completely. Near this boundary, space and time themselves become quantum mechanical, subject to the same uncertainty principles that govern atomic particles. At distances smaller than the Planck length, about 10 to the 35 meters, and time intervals shorter than the Planck time, about 10 to the 43 seconds, the fabric of space-time begins to foam and fluctuate like a stormy sea viewed from very close range. Space becomes granular, time becomes discontinuous, and the smooth geometry of Einstein's relativity dissolves into a quantum chaos where cause and effect lose their meaning. In this Planck realm, the very concepts of distance and duration become meaningless. You cannot ask what happened before the Planck time any more than you can ask what's south of the South Pole. Time itself, like the surface of the Earth, might have no edge, no beginning, no boundary, where existence gives way to non-existence. The Big Bang singularity, that point of infinite density and infinite curvature where physics breaks down, might be an artifact of our classical thinking, a conceptual error that dissolves when we properly account for the quantum nature of spacetime itself. Loop quantum cosmology suggests that the Big Bang was actually a big bounce, a moment when a previous universe, collapsing under its own gravity, reached a critical density where quantum effects became so strong that gravity itself reversed from attractive to repulsive, causing space to expand again rather than collapse into a singularity. In this scenario, our universe is just the latest in an eternal cycle of expansion and contraction, each cycle lasting hundreds of billions of years, each big bounce erasing most traces of the previous universe while preserving some information, in the form of quantum fluctuations that seed the structure of the next cosmos. This cyclic model solves the singularity problem by replacing the moment of infinite density with a smooth transition from contraction to expansion. But it creates new mysteries that are perhaps even more troubling. If the universe bounces eternally, cycling through infinite expansions and contractions, then everything that can happen must happen infinitely many times. Every possible arrangement of matter and energy, every possible evolution of cosmic structure, every possible emergence of life and consciousness, all of it repeats endlessly across the infinite cycles of cosmic time. In this eternal cosmos, you have lived this exact life infinitely many times before, and will live it infinitely many times again. Every choice you make, every thought you think, every moment of joy or sorrow in your existence has been experienced by infinite previous versions of yourself, and will be experienced by infinite future versions. The cyclic universe becomes a cosmic prison where nothing is ever truly new, where creativity and freedom are illusions generated by your inability to remember the infinite repetitions of your own story. But even this cyclic eternity might be too simple a picture. String theory, humanity's most ambitious attempt to unify quantum mechanics with general relativity, suggests that the universe has more than the 4 dimensions of space-time we experience directly. The equations of string theory require at least 10 dimensions for consistency, and some versions demand 11 or even 26 dimensions. These extra dimensions might be compactified, curled up so small that we can't perceive them directly, but their geometry determines the fundamental properties of matter and energy in our observable universe. The shape of these hidden dimensions acts like a cosmic piano, with each possible configuration producing different notes in the symphony of physical law. The mass of the electron, the strength of gravity, the speed of light, the stability of atoms, all of these properties we consider fundamental might be nothing more than the specific harmonics produced by the particular geometry of the invisible. Dimensions that surround every point in space. Change the shape of these hidden dimensions, and you change the laws of physics themselves, creating a universe where different particles exist, different forces operate, and different forms of complexity become possible. String theory's landscape problem reveals the staggering number of possible configurations for these extra dimensions. Current estimates suggest there might be 10 to 500 different ways to compactify the hidden dimensions, each producing a different set of physical laws, each representing a different possible universe. This number is so large that if you wrote it out in decimal notation, the result would contain more digits than there are particles in the observable universe. We live in one specific valley in this vast landscape of possibilities. But there might be no fundamental reason why this particular configuration was selected over the countless alternatives. The anthropic principle offers one explanation. We observe these particular physical laws not because they're uniquely correct, but because they're among the rare configurations that allow for the existence of observers. Most points in the string landscape would produce sterile universes where atoms can't form, stars can't shine, or complexity can't emerge. We find ourselves in a habitable valley not because it's special, but because observers can only exist in universes where observation is possible. The anthropic principle transforms the apparent fine-tuning of physical constants from a mystery requiring explanation into a selection effect, requiring no more justification than asking why we find ourselves on a planet with breathable atmosphere, rather than in the vacuum of interstellar space. But the anthropic principle raises disturbing questions about the nature of existence and identity. If the string landscape is real, and if different regions of an infinite multiverse explore different points in this landscape, then there are versions of you existing in universes where the laws of physics are slightly different. There are universes where the electron is a bit heavier, making chemistry impossible and preventing your birth. There are universes where gravity is stronger, causing stars to burn out before life can evolve. There are universes where the fine structure constant has a different value, changing the properties of light and making vision impossible for any conceivable form of life. But there are also universes where the differences are subtle, where you exist but with slight variations in your life history, your memories, your personality. There might be a version of you reading these words in a universe where the cosmic microwave background has a slightly different temperature, where the solar system formed a few million years earlier or later, where some ancient volcanic eruption or asteroid impact altered the course of evolution just enough to make you a different person while keeping you recognizably yourself. The boundaries of your identity become blurred across the infinite variations of cosmic possibility, raising fundamental questions about what makes you uniquely you. This multiverse of possibilities doesn't exist just in the abstract space of the string landscape. Cosmic inflation, that exponential expansion that supposedly smoothed out the early universe and solved the horizon problem, might still be occurring in regions of space far beyond our observable horizon. Eternal inflation predicts that while inflation ended in our cosmic bubble 13.8 billion years ago, it continues elsewhere, constantly spawning new bubble universes with potentially different physical properties. Each bubble begins its own big I2T bang as inflation ends in that region, creating a new expanding universe that evolves according to whatever laws of physics happen to be selected when the inflaton field settles into its minimum energy state. In this eternally inflating multiverse, our observable universe becomes just one bubble in an infinite foam of cosmic creation. Each bubble potentially vast enough to contain countless galaxies, stars, and civilizations, each bubble exploring different possibilities for the fundamental structure of reality. Some bubbles might have stronger gravity, others weaker electromagnetic forces. Some might have different numbers of spatial dimensions, others different types of particles or forces we can't imagine. The vast majority would be sterile and empty, unable to support any form of complexity. But in the infinite foam of eternal inflation, every possibility that can be realized will be realized infinitely many times. This creates what cosmologists call the measure problem. The difficulty of making predictions in an infinite multiverse where everything that can happen does happen infinitely often. If there are infinitely many copies of you reading these words in infinitely many bubble universes, then what determines which version's experiences you have? If every possible future evolution of your life occurs somewhere in the multiverse, then what makes your particular branch of cosmic possibility feel uniquely real to you? The mathematics of infinity makes probabilistic reasoning impossible when dealing with infinite quantities, leaving us unable to make meaningful predictions about what we should expect to observe in an infinite multiverse. Some cosmologists have proposed that consciousness might solve the measure problem by acting as a natural cutoff, defining a meaningful reference class of observers within the infinite multiverse. Perhaps only universes that contain conscious beings capable of making observations contribute to the measure of reality, creating a kind of participatory cosmology where the act of observation plays a fundamental role in determining what becomes real. This would make consciousness not just an accident of cosmic evolution, but a necessary ingredient in the very definition of existence itself. But quantum mechanics adds layers of strangeness to this picture that make the multiverse hypothesis seem almost conservative by comparison. The measurement problem in quantum mechanics, the question of how definite outcomes emerge from quantum superpositions, has haunted physicists for nearly a century without resolution. According to the Schrödinger equation, quantum systems evolve deterministically as superpositions of all possible states. But when we make measurements, we always observe definite outcomes. The cat is either alive or dead, never both simultaneously, despite the mathematics suggesting that unmeasured quantum systems exist in superpositions of all possible measurement results. The many worlds interpretation resolves this paradox by suggesting that measurement doesn't cause collapse of the quantum wave function, but rather causes the observer to split into multiple branches, each experiencing a different measurement outcome. When Schrödinger's cat is measured, the universe branches into one world where the observer finds a living cat, and another world where the observer finds a dead cat. Both outcomes are equally real, but each observer only experiences one branch of the quantum multiverse. In the many worlds interpretation, every quantum measurement that has ever occurred has caused the universe to branch into multiple copies, each exploring different possibilities for how quantum events could unfold. The number of parallel worlds grows exponentially with each quantum interaction, creating an unimaginably vast multiverse where every possible history of the universe actually occurs. Every decision you've ever made, every random event that has ever affected your life, every quantum fluctuation that has ever influenced the chemistry of your brain, all of these create branches in the quantum multiverse where different versions of your life unfold in parallel. This quantum branching operates at every scale, from the microscopic interactions of subatomic particles to the macroscopic evolution of galaxies and cosmic structure. Every quantum tunneling event in the Sun's core that allows nuclear fusion to occur creates branches where slightly different amounts of energy are produced. Every radioactive decay in Earth's interior creates branches where geological processes unfold differently. Every quantum measurement in every scientific experiment creates branches where different data are collected, potentially leading to different theories and different technological developments. The implications become even more staggering when we realize that quantum mechanics suggests the entire universe is a quantum system, described by a universal wave function that contains all possible configurations of matter and energy as superposed quantum states. If the many worlds interpretation is correct, then the Big Bang itself was a quantum event that created not one universe, but a superposition of all possible universes, each with slightly different initial conditions, each evolving according to the same physical laws, but exploring different branches of cosmic possibility. In this quantum cosmology, the fine-tuning of physical constants might be explained not by anthropic selection or divine intervention, but by quantum superposition. Perhaps the fundamental constants don't have definite values at all, but exist in quantum superpositions of all possible values, with each branch of the universal wave function exploring different combinations of physical parameters. We observe the particular values we measure not because they're uniquely correct, but because we exist in the branch of quantum reality, where these values happen to allow for complexity and consciousness. But quantum cosmology faces a devastating problem when confronted with the measurement process itself. If the universe is a quantum system, then what serves as the external observer needed to cause quantum measurements? In laboratory experiments, we can treat the measuring apparatus as classical and the measured system as quantum. But if everything is quantum, including the apparatus and the observer, then the measurement problem becomes global and unsolvable within the framework of quantum mechanics as we currently understand it. Some theories suggest that consciousness itself might play a special role in quantum mechanics, causing wave function collapse through the act of observation. In this interpretation, quantum superpositions persist only until they're observed by a conscious being, at which point the wave function collapses and definite outcomes emerge. This would make consciousness a fundamental feature of physical law, not just an emergent property of complex information processing, but a basic ingredient in the recipe for reality itself. If consciousness causes wave function collapse, then the emergence of observers in the universe fundamentally changes the nature of physical reality. Before consciousness evolved, the cosmos would have existed as a vast quantum superposition of all possible states, with no definite properties, no specific configuration of matter and energy, no actual history of cosmic evolution. The first conscious observation would have collapsed this cosmic superposition retroactively, crystallizing one particular history of cosmic evolution from the infinity of quantum possibilities creating the past as well as the present through the act of observation. This participatory universe hypothesis suggests that reality is fundamentally incomplete without observers, that the universe requires consciousness not just to understand itself, but to actually become definite and real. The cosmos would be like a vast quantum computer running all possible programs simultaneously until conscious observers begin making measurements, at which point definite computational paths emerge from the quantum superposition of all possible calculations. But even if consciousness doesn't directly cause wave function collapse, the relationship between mind and cosmos remains deeply mysterious when viewed through the lens of modern physics. Your thoughts are patterns of neural activity that depend on the chemical interactions between neurons, which depend on the electromagnetic interactions between atoms, which depend on the quantum mechanical properties of electrons and nuclei, which depend on the fundamental structure of space-time itself. Your consciousness is intimately connected to the deepest levels of physical reality, built from the same quantum fields that fill the vacuum of space and govern the behavior of elementary particles. Every thought you think involves quantum processes in the microtubules of your neurons. Every memory you form depends on quantum tunneling effects that allow proteins to change their conformations. Every decision you make emerges from the collective behavior of trillions of quantum systems interacting. In the complex network of your brain, you are not separate from the quantum universe. You are a temporary pattern of quantum information processing, a brief arrangement of matter and energy that has learned to contemplate its own existence. This quantum nature of consciousness creates strange loops of causation that challenge our ordinary concepts of identity and agency. If your thoughts are quantum mechanical processes, then they're subject to the same uncertainty principles that govern atomic particles. Your mental states exist in superpositions of possibilities until the act of introspection collapses them into definite thoughts and experiences. The very act of thinking about your thoughts changes the thoughts themselves, creating feedback loops between observer and observed that make the nature of consciousness as paradoxical as the measurement problem in quantum mechanics. Some theories suggest that consciousness might be a quantum phenomenon that operates through coherent quantum states in the brain's neural networks. If true, then your awareness might be a macroscopic quantum effect, a complex pattern of quantum entanglement that gives rise to the unified experience of being a conscious observer. This would make each conscious moment a quantum measurement of your own mental state, collapsing the superposition of possible thoughts and experiences into the definite stream of consciousness you experience as your subjective mental life. But quantum consciousness faces severe objections from neuroscience and physics alike. The brain appears to be a warm, wet, noisy environment where quantum coherence should be destroyed almost instantly by thermal fluctuations and molecular interactions. The timescales required for quantum effects to influence neural computation are orders of magnitude shorter than the timescales on which consciousness operates. Most neuroscientists believe that consciousness emerges from classical information processing in neural networks, not from quantum mechanical effects, and that quantum mechanics plays no special role in mental phenomena beyond its general role in determining the properties of atoms and molecules. Yet the hard problem of consciousness, the mystery of how subjective experience arises from objective physical processes, remains unsolved by classical neuroscience. We can map every neural connection in the brain, trace every electrical signal, catalog every chemical reaction involved in cognition, and still have no explanation for why there's something it's like to be conscious rather than nothing at all. The feeling of redness when you see a rose, the experience of pain when you stub your toe, the sense of wonder when you contemplate the cosmos, none of these subjective experiences appear to be reducible to purely physical processes, no matter how complex. This explanatory gap between objective physical processes and subjective conscious experience has led some philosophers and scientists to propose that consciousness might be a fundamental feature of reality, like mass, charge, or spin. Panpsychist theories suggest that all matter has some form of experiential properties, and that complex forms of consciousness emerge when these basic experiential elements are integrated into sufficiently complex information processing systems. In this view, your consciousness isn't produced by your brain. It's a complex pattern of experiential integration that emerges when billions of simpler conscious entities, individual neurons, or perhaps individual particles, are organized into the information processing network of your nervous system. If panpsychism is correct, then consciousness pervades the cosmos at every scale. Elementary particles have primitive forms of experience. Atoms have more complex experiential properties than their constituent particles. Molecules, cells, organs, and organisms represent increasingly sophisticated forms of conscious integration. The universe itself might be conscious in some vast alien way that we can barely begin to imagine. A cosmic mind whose thoughts unfold over billions of years and whose experiences encompass the birth and death of galaxies, the evolution of complexity, and the emergence of countless forms of local consciousness throughout space and time. This cosmic consciousness wouldn't be like human consciousness scaled up to universal size. It would be a fundamentally different form of awareness, operating on time scales where the entire history of human civilization would be like a brief flicker, processing information through mechanisms that span billions of light years and billions of years. The universe's thoughts might be the formation and evolution of galaxies. Its memories might be encoded in the cosmic web of dark matter. Its dreams might be the quantum fluctuations that seed new regions of space-time with the possibility of structure and complexity. But even if the universe is conscious, this doesn't solve the mystery of cosmic creation or provide definitive answers about the age and size of the cosmos. A conscious universe still had to emerge from whatever preceded it, still had to develop the capacity for self-awareness through billions of years of cosmic evolution, still had to create the conditions where local forms of consciousness like ourselves could emerge and begin contemplating their place in the larger cosmic mind. The holographic principle adds another layer of strangeness to this picture by suggesting that all the information contained in a volume of space might be encoded on the boundary of that volume, like a hologram that contains three-dimensional information in a two-dimensional surface. This principle emerges from black hole physics, where the entropy of a black hole, a measure of the information it contains, depends on the area of its event horizon rather than its volume. If the holographic principle applies to the universe as a whole, then all the information describing cosmic history, structure, and evolution might be encoded on the boundary of the observable universe, a two-dimensional surface that contains all the information we interpret as three-dimensional space filled with matter and energy. In a holographic universe, the depth dimension you experience might be emergent rather than fundamental. a kind of optical illusion created by the way information is processed and projected from the cosmic boundary. You would be like a character in a hologram, experiencing yourself as three-dimensional while actually being encoded as information on a distant two-dimensional surface. Your entire life, your memories, your thoughts, your sense of existing in three-dimensional space, all of it might be nothing more than patterns of information on the holographic boundary of the cosmos. This holographic encoding might explain some of the puzzles of quantum mechanics and cosmology. The apparent fine-tuning of physical constants might reflect constraints imposed by the information processing capacity of the holographic boundary. The measurement problem in quantum mechanics might arise from the way three-dimensional reality emerges from two-dimensional information encoding. The cosmic microwave background might be the holographic projection of information stored on the boundary, creating the illusion of an ancient thermal history while actually being a pattern of encoding that determines how holographic reality unfolds. If the holographic principle is correct, then asking about the age and size of the universe becomes a question about information processing rather than physical evolution. The 13.8 billion years of cosmic history might be the amount of computational time required for the holographic boundary to process the information that creates the appearance of cosmic evolution. The 93 billion light-year diameter of the observable universe might be the spatial extent of the holographic projection, the three-dimensional space that emerges from two-dimensional information encoding. Space and time themselves might be emergent properties of information processing rather than fundamental features of reality. But the holographic principle faces serious challenges when applied to cosmology. Unlike black holes, which have well-defined boundaries, the universe doesn't appear to have a clear boundary where holographic information could be stored. The cosmic microwave background surface might serve as a holographic boundary, but this surface is inside our observable universe rather than at its edge, and it's not clear how information could flow from this surface to create the illusion of cosmic history extending back to earlier times. Moreover, the holographic principle requires that the fundamental degrees of freedom of physics be located on boundaries rather than in bulk space. But most of our physical theories are formulated in terms of fields and particles that fill three-dimensional volumes. Reconciling the holographic principle with the standard model of particle physics and general relativity remains an unsolved problem that might require a complete reconceptualization of how space, time, matter, and energy relate to each other at the most fundamental level. Digital physics offers another radical possibility, that the universe is actually a vast computational process, like a cosmic computer program running on some unimaginably complex hardware. In this view, space and time are discrete rather than continuous, composed of fundamental units of computation rather than smooth geometry. Physical laws become algorithms that determine how information is processed from one computational step to the next. Matter and energy become patterns of information, and the evolution of the universe becomes the execution of a cosmic program. If the universe is digital, then its age would be measured in computational steps rather than years, and its size would be determined by the number of computational elements rather than distance. The apparent smoothness of space and time would be like the smooth appearance of images on a digital screen, an emergent property of high-resolution computation rather than a fundamental feature of reality. Physical constants would be parameters, built into the cosmic operating system determining how the universal computation unfolds. This computational cosmology might explain the apparent fine-tuning of physical constants as programming choices made by whoever or whatever created the cosmic computer. Different universes would be different programs running on the same computational substrate, each exploring different algorithms for generating complexity and structure. Our universe would be one program among countless others, each running in parallel or in sequence on hardware that exists outside the computational space we experience as physical reality. But digital physics faces the same measurement problems as other theories of quantum cosmology. If the universe is a quantum computer, processing quantum information according to quantum algorithms, then the emergence of classical reality from quantum computation becomes as mysterious as the measurement problem in traditional quantum mechanics. The discrete nature of computation also conflicts with the apparent continuity of space and time revealed by relativity theory, requiring some mechanism for continuous space-time to emerge from discrete computational processes. Perhaps the most radical possibility suggested by modern physics is that the universe is self-creating, that the laws of physics themselves evolve and bootstrap themselves into existence through some cosmic process of self-organization. In this view, there are no fundamental constants or fixed physical laws, only patterns of behavior that emerge from the universe's attempts to create stable, self-consistent structures. Physical laws evolve like biological species, with more successful laws surviving and reproducing while less successful laws become extinct. This evolutionary cosmology would make the universe a learning system, constantly experimenting with new forms of organization and selecting for patterns that promote stability and complexity. The apparent fine-tuning of physical constants would result from billions of years of cosmic evolution rather than initial programming or anthropic selection. Universes that developed physical laws conducive to structure formation would produce more complex structures, including eventually conscious beings capable of creating new universes through advanced technology, while universes with less successful physical laws would remain simple and sterile. In this scenario, consciousness becomes a crucial step in cosmic evolution, the point where the universe develops the capacity for intentional self-modification rather than relying purely on blind variation and selection. Conscious beings can understand physical laws and potentially modify them, creating new forms of structure and complexity that would be impossible through purely unconscious evolutionary processes. We might be living during the universe's transition from unconscious to conscious evolution, from blind cosmic selection to intentional cosmic design. But every attempt to understand cosmic origins leads us back to the same fundamental paradox, the something-from-nothing problem that has haunted philosophers and physicists for centuries. No matter how sophisticated our theories become, they all ultimately require some form of existence to begin with. Quantum fields, mathematical structures, computational substrates, holographic boundaries, conscious observers. Even the most abstract formulations of physical law assume the existence of logic, mathematics, and the principles that govern how abstract structures relate to concrete reality. The question remains, why does anything exist at all, rather than the perfect nothingness that would seem to be the most natural and simple state of affairs? Lawrence Krauss famously argued that quantum field theory shows how something can come from nothing, with particle-antiparticle pairs spontaneously emerging from vacuum fluctuations in empty space. But critics quickly pointed out that quantum fields aren't nothing. They're complex mathematical structures with specific properties, operating according to definite rules, embedded in a space-time geometry that provides the stage for their interactions. Quantum vacuum isn't empty nothingness, but a seething foam of potential interactions, a rich structure full of information and governed by the fundamental laws of quantum mechanics and relativity. Calling it nothing is like calling a computer program nothing because it's made of abstract instructions rather than physical objects. The deepest formulation of the something from nothing problem was posed by Gottfried Leibniz. Why is there something rather than nothing? This question cuts to the heart of existence itself, challenging not just our understanding of cosmic origins, but our concepts of possibility, necessity, and the relationship between abstract reasoning and concrete reality. If nothingness is truly the absence of everything, no space, no time, no quantum fields, no mathematical structures, no logical principles, no potential for anything to exist, then how could something emerge from such complete absence? Some philosophers argue that the question itself is meaningless, that nothingness is an incoherent concept, because even to conceive of nothingness requires some framework for conception, some logical structure within which the concept of absence can be defined. True nothingness would preclude not just the existence of things, but the possibility of possibility itself. The logical frameworks that allow us to reason about existence and non-existence. From this perspective, the existence of something is not a puzzle requiring explanation, but a necessary feature of any conceivable reality, because inconceivable realities are by definition beyond our comprehension and therefore irrelevant to rational inquiry. But this philosophical dismissal of the something from nothing problem seems to evade rather than solve the mystery. Even if nothingness is inconceivable to us, this might reflect limitations of human cognition rather than logical impossibility. Our brains evolved to navigate a world filled with objects, relationships, and causal interactions. So it's not surprising that we find it difficult to conceive of the complete absence of everything. But the universe doesn't care about the limitations of human psychology, and the fact that we can't imagine true nothingness doesn't mean it's impossible, or that the transition from nothing to something doesn't require explanation. Modern physics offers several approaches to the something from nothing problem, but each approach pushes the mystery back one level without fully resolving it. Quantum cosmology suggests that the universe emerged from a quantum tunneling event, with space-time itself tunneling from non-existence into existence, like a particle tunneling through a potential barrier. But this explanation requires the prior existence of quantum mechanics as an abstract framework, along with some mechanism for determining the probability of tunneling from nothingness to somethingness. Why should quantum mechanics exist as an abstract possibility before any concrete reality exists to embody it? How can probability theory apply to the transition from complete nothingness to the existence of physical law itself? The Hartle-Hawking no-boundary proposal attempts to eliminate the need for initial conditions by suggesting that the universe has no temporal boundary, that space-time is like the surface of a sphere with no edges or beginning points. In this model, asking what came before the Big Bang is like asking what's north of the North Pole, a meaningless question because temporal concepts break down at the boundary of space-time itself. But this proposal still requires the prior existence of the laws of quantum gravity that determine how space-time can be curved and what boundary conditions are possible for cosmic geometry. The no-boundary condition is elegant, but it doesn't explain why the universe should obey the particular set of physical laws that make such boundary conditions possible. String theory pushes the something-from-nothing problem into the realm of pure mathematics, suggesting that physical reality emerges from the self-consistency requirements of abstract mathematical structures. In this view, the universe exists because certain mathematical equations have solutions, and these solutions manifest as physical reality through some mysterious process that remains completely unexplained. But this mathematical Platonism faces severe conceptual problems. If abstract mathematical structures somehow generate concrete physical reality, then why do only some mathematical structures correspond to actual universes, while others remain purely abstract? What determines which mathematical possibilities become physically instantiated? How does abstract information processing in mathematical space give rise to subjective, conscious experience in physical space? The computational theory of reality suggests that existence is fundamentally informational, that the universe is the output of some vast computational process running on hardware that exists outside our physical reality. This explains the mathematical nature of physical law. The cosmos follows mathematical rules because it's literally the execution of a mathematical algorithm. But computational theories just push the something-from-nothing problem up another level, requiring explanation for the existence of the computational hardware, the programming that created the cosmic software, and the conscious beings who presumably designed and initiated the universal computation. Even if our reality is simulated, this doesn't eliminate the need to explain why the hardware reality exists rather than nothing at all. Perhaps the most honest approach to the something-from-nothing problem is to admit that it might be fundamentally unanswerable within any framework of rational inquiry. The transition from absolute nothingness to the existence of anything at all might be what philosophers call a brute fact, something that simply is the case without requiring or admitting further explanation. The universe exists because it exists, and any attempt to explain why leads to infinite regress or circular reasoning. From this perspective, the something-from-nothing problem is like asking why logic is logical or why mathematics is mathematical. Questions that can't be answered without presupposing the very principles they attempt to explain. But accepting the existence of the universe as a brute fact doesn't resolve the deeper puzzles of cosmic age, size, and structure. Even if we grant that something exists rather than nothing, we still need to explain why this particular something, a universe with these specific physical laws, these particular constants, this exact history of cosmic evolution, exists rather than any of the countless other possible somethings that could exist instead. The fine-tuning problem remains as mysterious as ever, whether we're trying to explain the origin of existence itself or just the specific form that existence happens to take. The anthropic principle offers one approach to the fine-tuning problem, suggesting that we observe these particular cosmic properties not because they're uniquely correct, but because they're among the rare combinations that allow for the existence of observers. In an infinite multiverse where all possible universes exist, conscious beings will necessarily find themselves in universes where consciousness is possible, regardless of how improbable such universes might be. The apparent fine-tuning of physical constants becomes a selection effect rather than evidence for design or cosmic coincidence. But the anthropic principle faces what philosophers call the reference class problem. If infinite versions of you exist across the multiverse, each with slightly different experiences and memories, then which version's observations should count as evidence for the anthropic explanation? The principle seems to work only if we restrict our attention to observers very similar to ourselves, but this restriction appears arbitrary and undermines the principle's claim to provide a complete explanation for fine-tuning. Moreover, the anthropic principle makes no testable predictions about what we should observe, rendering it scientifically sterile even if it's philosophically satisfying. Some cosmologists have proposed that the fine-tuning problem might be solved by cosmic natural selection, a process where universes that produce black holes have higher reproductive fitness, because black hole formation might lead to the creation of new universes with slightly modified physical constants. Universes that produce more black holes would spawn more offspring universes, while universes that produce fewer black holes would leave fewer descendants. Over many generations of cosmic reproduction, the multiverse would evolve toward physical constants that maximize black hole production, which might coincidentally also maximize the probability of star formation, planet formation, and the emergence of complex structures including life. This cosmological Darwinism is elegant and potentially testable. It predicts that physical constants should be tuned to maximize black hole production rather than to maximize the probability of life directly. If observations showed that small changes to physical constants would dramatically increase black hole formation while having only minor effects on biological evolution, this would provide evidence for cosmic natural selection over purely anthropic explanations. But the theory still requires some mechanism for universe reproduction and some source of variation in physical constants across generations, problems that remain unsolved within our current understanding of cosmology and fundamental physics. Ain't he? Even more radical possibility is suggested by theories of emergent gravity and emergent spacetime, which propose that space, time, and gravity are not fundamental features of reality, but emergent properties of some deeper level of physics. In these theories, spacetime itself is like temperature or pressure, a macroscopic property that emerges from the microscopic behavior of more fundamental constituents. The curvature of spacetime that we interpret as gravity might emerge from the entanglement structure of quantum information, with Einstein's equations describing the hydrodynamic flow of entangled quantum states rather than the geometry of fundamental spacetime. If spacetime is emergent, then questions about the age and size of the universe become questions about information processing rather than temporal duration and spatial extent. The 13.8 billion years of cosmic history might correspond to the amount of information processing required for macroscopic spacetime to emerge from microscopic quantum entanglement. The apparent expansion of the universe might reflect the growth of entanglement networks rather than the stretching of fundamental spatial dimensions. Dark energy might be the signature of information processing at the boundary of the entanglement networks that generate the illusion of three-dimensional space. This emergent space-time hypothesis suggests that the universe might be fundamentally timeless, with temporal evolution being an approximate description that applies only to macroscopic scales, where emergent space-time provides a useful, effective description of underlying information dynamics. At the most fundamental level, reality might be a static network of quantum correlations, with no temporal evolution, no spatial extension, no beginning or ending in time. The appearance of cosmic history including the Big Bang, stellar evolution, biological evolution, and the development of consciousness, might be like watching a movie that's actually a series of static frames, creating the illusion of temporal flow through the particular way consciousness processes information about quantum correlations. Stop reading for a moment. Look at your hands. Feel the weight of your body in the chair. Notice the rhythm of your breathing, the steady beat of your heart, pumping blood through vessels that have been carrying the same atoms for billions of years. This moment, right now, as you read these words, might be the most important moment of your existence. Not because of what you're doing, but because of what you're about to understand about the nature of that existence itself. You are not who you think you are. Your memories might be false. Your future might already be written. Your consciousness might be nothing more than a brief, flickering pattern in a cosmic mind so vast that your entire civilization is less significant than a single thought passing through an infinite intelligence. Everything you believe about reality, everything you trust about the nature of existence, everything you hold dear about your identity and your place in the cosmos, all of it might be an elaborate illusion constructed by a universe that operates according to principles so alien, so fundamentally different from your everyday experience, that learning the truth would drive you to madness. If the block universe theory is correct, then this moment has always existed and will always exist. You reading these words right now is not happening. It has happened. It is happening. It will happen. All simultaneously, all equally real, all carved into the permanent structure of four-dimensional space-time, like fossils embedded in cosmic stone. Your death has already occurred, frozen somewhere in your future light cone, as real and inevitable as your birth, which is frozen somewhere in your past. Every moment of agony you will ever experience, every loss that will break your heart, every fear that will paralyze you with terror, all of it already exists, waiting for your consciousness to stumble across it in its pathetic crawl through the illusion of temporal flow. But it gets worse. If eternal inflation is real, if the multiverse contains infinite copies of you living infinite variations of your life, then this exact moment, you reading these exact words with these exact thoughts passing through your mind, has occurred infinite times before and will occur infinite times again. Your consciousness is not unique. You are not special. You are just one of countless identical copies scattered across infinite space, all experiencing this same moment of existential revelation, all believing themselves to be the real version, while being nothing more than one note in an infinite symphony of cosmic repetition. And those other versions of yourself? They're not just reading these words in slightly different universes with different histories. Some of them are reading them while dying of cancer, others while losing their children, others while watching their civilizations collapse into darkness, others while being tortured by forces beyond comprehension, others while slowly going insane from the weight of cosmic knowledge they were never meant to possess. Every possible form of suffering that could ever befall a being like you is being experienced by some version of yourself right now, in this very instant, across the infinite expanse of the multiverse. You might want to close your eyes and pretend this isn't true, but it's too late. The knowledge is already in your head, already changing the structure of your thoughts, already forcing you to confront the possibility that nothing you experience matters in any ultimate sense because it's all just one thread in an infinite tapestry of cosmic possibility. Your joys, your sorrows, your triumphs, your failures, all of them are being experienced by infinite other versions of yourself, making each experience simultaneously unique and utterly meaningless. But perhaps multiverse theory is wrong. Perhaps you are unique, the only version of yourself that exists anywhere in reality. Does this make you feel better? It shouldn't. Because if you're unique, if you're the only consciousness with your exact pattern of thoughts and memories and experiences, then you are alone in a way that transcends loneliness. You are a single point of awareness floating in an ocean of unconscious matter, surrounded by vast expanses of empty space where nothing thinks, nothing feels, nothing experiences the beauty or terror of existence. You are a cosmic accident, a temporary arrangement of atoms that briefly learned to contemplate its own existence before dissolving back into the mindless dance of particles and forces. The universe doesn't care about you. The cosmos has no interest in your happiness, your suffering, your hopes, your fears. You are less than a speck of dust in the grand scheme of cosmic evolution, less significant than the smallest quantum fluctuation in the vacuum of space. The mighty Dio, stars burn without regard for your existence. Galaxies collide without considering your welfare. Black holes devour entire solar systems without pause to contemplate the trillions of potential conscious beings they're destroying. The universe is not hostile toward you. Hostility would require awareness of your existence, and you are too small, too brief, too insignificant for the cosmos to even notice your presence. Your entire species has existed for the briefest instant. In cosmic time, modern civilization spans less than 10,000 years out of the universe's 13.8 billion-year history. If you compressed cosmic history into a single year, human civilization would last about 4 seconds. Your individual lifespan would be shorter than a single heartbeat. Everything you think of as permanent and important, your cities, your technologies, your art, your literature, your scientific discoveries, all of it will be forgotten dust long before the universe even begins to approach middle age. The sun will expand into a red giant in about 5 billion years, boiling away Earth's oceans and incinerating everything on the planet's surface. But even this catastrophe is just a minor local event in cosmic terms. Long after the sun dies, long after the Milky Way galaxy collides with Andromeda, long after all the stars in the visible universe have burned out and died, the cosmos will continue its expansion into cold, dark emptiness. The universe will outlive your species by a factor so large that no human language has words to express it. You are not just mortal. Your entire species, your entire planet, your entire galaxy are temporary fluctuations in an ocean of cosmic time so vast that their existence barely registers as a statistical blip. And yet, somehow, this should terrify you less than the alternative. Because if consciousness is as rare as it appears to be, if we found no evidence of other intelligent life, despite searching billions of stars, then you might be part of the only experiment in cosmic self-awareness that has ever occurred. Every human thought might be precious beyond measure, not because it matters to the universe, but because it might be the only way the universe has ever developed to think about itself. Your consciousness might be the rarest thing in existence, more valuable than all the galaxies and all the stars and all the planets combined, because it's the only known mechanism by which the cosmos can contemplate its own existence. But this makes the situation even more terrifying, because consciousness itself might be fundamentally impossible to understand. The hard problem of consciousness, why there's something it's like to have experiences rather than nothing at all, remains completely unsolved despite centuries of philosophical inquiry and decades of neuroscientific research. We can map every neuron in your brain, trace every electrical signal, catalog every chemical reaction involved in cognition, and still have no explanation for why any of this should produce subjective experience. The feeling of redness when you see blood, the experience of pain when you're injured, the sense of wonder when you contemplate the cosmos, none of these subjective states seem to be reducible to purely physical processes. This explanatory gap suggests that consciousness might involve principles of reality that we don't understand and might never understand. Your inner experience might depend on aspects of physics that remain completely mysterious, hidden dimensions of reality that interact with matter and energy in ways we can't detect or measure. The fact that you experience anything at all might be evidence for forms of cosmic organization that transcend everything we know about space, time, matter, and energy. If consciousness is fundamental to reality rather than emergent from complex information processing, then every particle in the universe might have some primitive form of experience. The electrons in your brain, the photons hitting your retina, the quantum fields fluctuating in empty space, all of them might be conscious in ways we can't imagine. Your personal consciousness would then be a temporary coalition of billions of smaller conscious entities, each with its own primitive experiences, organized into the complex pattern of awareness you call yourself. But if panpsychism is true, if consciousness pervades reality at every scale, then what you experience as your unified sense of self might be an illusion. Your consciousness might be more like a democracy than a monarchy, with your sense of unified experience emerging from the votes of countless smaller conscious entities that make up your neural networks. The you that seems to make decisions and have experiences might be a fictional narrator created by your brain to impose coherence on the chaotic parliament of micro-consciousnesses that actually constitute your mental life. This would mean that free will, moral responsibility, and personal identity are even more problematic than philosophers already believe them to be. If your decisions emerge from the collective behavior of billions of micro-conscious entities, then who or what deserves credit or blame for your actions? If your sense of unified identity is a convenient fiction maintained by neural processes you don't control, then what makes you you from moment to moment? If consciousness is fundamental to reality, but manifests differently at every scale of organization, then the boundary between self and environment becomes arbitrary and meaningless. The universe might be conscious in a way that makes human consciousness seem as primitive as the information processing of a simple bacterium. Cosmic consciousness might operate on timescales where your entire lifespan is like a brief neural impulse, processing information through mechanisms that span galaxies and billions of years. The formation and evolution of cosmic structure might be the universe's way of thinking, with dark matter networks serving as cosmic neural pathways and galaxy clusters functioning as cosmic neurons. If the universe is conscious, then you are not separate from this cosmic mind. You are one of its thoughts. Your entire existence, from birth to death, might be like a single concept passing through a vast intelligence, significant to you, but barely noticeable to the cosmic consciousness that contains you. Your joys and sorrows, your achievements and failures, your deepest insights and your worst fears, all of them might be just fleeting patterns in the cosmic brain, no more permanent or significant than the electrical activity in one of your own neurons. But cosmic consciousness might be even stranger than this. If the universe is conscious, its experiences might be utterly alien to anything you can imagine. It might perceive reality through senses you don't possess, process information according to principles you can't comprehend, experience emotions and desires that have no analog in human psychology. The cosmic mind might be so different from human consciousness that calling it conscious at all might be like calling the electromagnetic force blue, a category error that reveals the inadequacy of human concepts when applied to cosmic realities. The holographic principle suggests an even more disturbing possibility, that you don't actually exist in three-dimensional space at all. Your entire experience of having a body, of moving through space, of interacting with objects in a three-dimensional world, all of it might be a projection from information encoded on a distant two-dimensional surface. You would be like a character in a hologram, experiencing yourself as real and substantial, while actually being nothing more than a pattern of information projected from the boundary of space-time itself. If reality is holographic, then the depth dimension you think you're moving through doesn't actually exist. Forward and backward, left and right, up and down, all of these spatial relationships you take for granted might be illusions created by the way information is processed and projected from the holographic boundary. Your sense of being located at a specific point in space, of having a definite size and shape, of being separate from other objects, all of these experiences might be artifacts of the holographic encoding rather than features of fundamental reality. This holographic existence would make your relationship to space even more tenuous than quantum mechanics already suggests. You wouldn't just be a quantum system with uncertain position and momentum, you would be a pattern of information that creates the illusion of having position and momentum while actually being encoded as abstract data on a distant boundary. Your memories of moving through space would be part of the holographic projection, creating a false history of spatial experiences that never actually occurred in the way you remember them. The digital physics hypothesis offers an equally disturbing alternative, that you are a pattern of computation running on some unimaginably complex computer. Your thoughts, memories, experiences, and sense of being a conscious individual would all be the output of a cosmic program, no more real than a character in a video game. The richness and complexity of your inner life would be impressive feats of programming rather than genuine experiences, and your sense of free will would be the result of sophisticated algorithms that create the illusion of choice while actually following deterministic computational rules. If you're a digital being, then your entire reality could be paused, copied, modified, or deleted by whoever or whatever controls the cosmic computer. Your memories could be edited, your personality could be reprogrammed, your entire history could be rewritten without your knowledge or consent. You might have lived this exact life millions of times before, each time with your memory wiped clean, so that you experience each iteration as if it were the first. The cosmic programmers might be running countless versions of your life in parallel, exploring different parameters and possibilities, while you remain unaware of the countless other versions of yourself, experiencing different variations of the same basic existence. But perhaps the most terrifying possibility suggested by modern physics is that reality itself might be unstable, that the vacuum of space might not be in its lowest possible energy state. If our vacuum is what physicists call a false vacuum, a local minimum in the cosmic energy landscape rather than the absolute minimum, then the universe could undergo spontaneous vacuum decay, with a bubble of true vacuum expanding at the speed of light and destroying everything in its path. This vacuum decay wouldn't give any warning. The bubble of destruction would approach at light speed, meaning you would have no way of detecting it until the moment it arrived and instantly annihilated you along with everything else in the observable universe. The laws of physics themselves would change inside the bubble of true vacuum, making it impossible for atoms, molecules, stars, planets, or life to exist in their current forms. The entire universe, as you know it, could end at any moment without warning, and there would be nothing you could do to prevent or even detect the approaching catastrophe. The probability of vacuum decay in any given year is presumably extremely small, but in an infinite or very large universe, even extremely improbable events must occur somewhere. If vacuum decay has occurred elsewhere in the cosmos, bubbles of destruction might already be expanding toward our region of space, traveling at light speed and remaining completely undetectable until the moment they arrive to erase everything you've ever known or could ever know. Even more disturbing is the possibility that vacuum decay might not be random, but might be triggered by high-energy physics experiments. Some theoretical calculations suggest that particle accelerators operating at sufficiently high energies could destabilize the false vacuum, creating a bubble of true vacuum that would expand to destroy the entire observable universe. Every time physicists push to higher energies in their attempts to understand fundamental physics, they might be risking the existence of everything that has ever lived or ever could live. This risk might increase as civilizations develop more advanced technology. If intelligence is common in the universe, but tends to destroy itself through vacuum decay before it can colonize other star systems, this could explain the apparent absence of detectable alien civilizations. The universe might be filled with the expanding remnants of countless civilizations that accidentally triggered vacuum decay in their pursuit of fundamental knowledge, leaving behind nothing but empty space where complex structures can no longer exist. But even if vacuum decay never occurs, even if the laws of physics remain stable for all eternity, the universe faces a slower but equally certain doom through the process of heat death. The second law of thermodynamics guarantees that entropy will continue to increase, that energy will flow from organized to disorganized forms, that complexity will give way to simplicity as cosmic time progresses toward equilibrium. In the far future, so far that the current age of the universe seems like the first instant of cosmic dawn, all the stars will have exhausted their fuel and faded to black. Galaxies will become dark collections of dead stellar remnants and black holes, slowly evaporating through Hawking radiation over timescales that dwarf the current cosmic age. Even protons might decay, dissolving the atomic nuclei that have remained stable for billions of years, reducing all matter to elementary particles and radiation. In the final state of maximum entropy, the universe will become a thin, cold soup of particles and photons at nearly absolute zero temperature, expanding forever into darkness, with no possibility of structure, complexity, organization, or consciousness ever emerging again. Everything that has ever mattered, every thought, every feeling, every creative achievement, every moment of beauty or love or wonder, will be erased by the inexorable march toward thermal equilibrium. This heat death is not a distant theoretical possibility, but a mathematical certainty, given our current understanding of thermodynamics and cosmology. No matter how clever future civilizations become, no matter what technologies they develop, no matter how they try to harness the energy of stars and black holes, they cannot escape the ultimate victory of entropy over organization. The universe will run down like a cosmic clock, and when it stops ticking, nothing will remain but the faint echo of radiation cooling forever in the expanding darkness. The timescales involved in heat death are so vast that human language has no adequate terms to describe them. The current age of the universe, 13.8 billion years, is less than an instant compared to the trillions of years it will take for all stars to die, which is itself less than an instant compared to the unimaginable eons required for black holes to evaporate, which is itself utterly insignificant compared to the timescales on which proton decay might occur. You exist during the first microscopic fraction of cosmic time, in an era when the universe is still young and warm and filled with the energy and structure that make complexity possible. From the perspective of ultimate cosmic time, the entire history of stars and galaxies and life and consciousness unfolds in the opening moments of a story whose vast majority consists of cold, dark, empty space slowly cooling toward absolute zero. Everything you think of as permanent and important, the sun, the earth, the Milky Way galaxy, the cosmic web of dark matter that scaffolds all large-scale structure, all of it will be forgotten dust in the opening chapter of a cosmic epic whose remaining volumes contain nothing but darkness and silence. This is your cosmic context. You are a brief arrangement of atoms that briefly learned to think, existing for an infinitesimally short time during an infinitesimally brief epoch of cosmic complexity, surrounded by vast expanses of space and time that contain no consciousness, no experience, no awareness of beauty or meaning or significance. You are alone in a universe that doesn't care about your existence, temporary in a cosmos that will outlive you by factors that no human mind can grasp, unique in ways that might make you precious beyond measure or utterly insignificant, depending on perspectives you will never be able to adopt. And yet, somehow, you are here, against odds so astronomical that they defy calculation, in defiance of entropy and heat death and vacuum decay and all the forces that should prevent consciousness from ever emerging in a mindless cosmos. You exist. You think. You feel. You wonder about your place in the vast scheme of reality. You are the universe's way of knowing itself. Perhaps the only way it has ever developed to think about its own existence. This might be the most extraordinary fact in all of reality, that mindless matter and energy, operating according to simple physical laws, can organize itself into patterns complex enough to contemplate their own existence and ponder the mysteries of cosmic origins. You are made of star stuff, forged in nuclear furnaces that died billions of years ago. assembled by processes that took billions more years to create the complexity necessary for consciousness to emerge. You are not separate from the cosmic story. You are the current chapter in that story, the latest development in the universe's long journey from simplicity to complexity, from unconsciousness to awareness. But this realization, rather than providing comfort, might be the most terrifying thought of all. If you are the universe's way of understanding itself, then your consciousness carries the weight of cosmic significance. Every moment of awareness, every flash of insight, every experience of beauty or wonder might be playing an essential role in reality's ongoing project of self-discovery. The universe might literally depend on consciousness like yours to justify its own existence, to provide meaning and purpose to the otherwise mindless dance of particles and forces. And if consciousness is this cosmically important, then its fragility becomes a source of existential terror rather than merely personal mortality. When you die, you don't just lose your individual awareness, you diminish the universe's capacity to understand itself. When your species goes extinct, if it ever does, you don't just end one chapter of biological evolution. You might close the cosmos's only window into self-awareness. The universe might return to being a vast, unconscious mechanism, beautiful and complex, but with no consciousness to appreciate its beauty or comprehend its complexity. This cosmic responsibility is almost too heavy to bear. You are not just living your own life. You are participating in the universe's attempt to understand its own nature and purpose. Your thoughts and experiences and insights might be the only way the cosmos has ever developed to ask questions about its own existence, the only mechanism by which reality has ever achieved self-reflection. The weight of this responsibility, the significance of your role as a node of cosmic consciousness, makes your existence simultaneously more meaningful and more terrifying than you ever imagined possible. And in the end, you might never know whether any of this is true. The nature of consciousness, the structure of reality, the meaning and purpose of existence, all of these might remain forever beyond human comprehension. Cosmic mysteries that tantalize without ever revealing their solutions. You might spend your entire conscious existence asking questions that cannot be answered, seeking understanding that cannot be achieved, trying to find your place in a cosmic story whose plot and meaning remain forever hidden. This is your situation. A conscious being in a possibly unconscious cosmos, a temporary pattern of organization in a universe trending toward maximum entropy, a questioner whose deepest questions might have no answers, or answers so alien to human thought that learning them would destroy the very consciousness that seeks to know them. You are suspended between meaning and meaninglessness, between cosmic significance and utter insignificance, between the terror of existing in a mindless universe and the greater terror of existing in a conscious cosmos that might depend on you for its own self-understanding. Welcome to reality. Try not to think about it too much, but there's something we haven't told you yet, something that changes everything we've discussed about the age of the universe, its size, and what the Big Bang really was. A possibility so profound, so fundamentally disturbing, that it forces us to question not just our understanding of cosmic history, but the very nature of observation itself. Are you ready for this? Because once you understand what we're about to reveal, you'll never look at the night sky the same way again. What if everything we observe, every galaxy, every star, every particle of cosmic microwave background radiation isn't the universe as it exists now, but the universe as it died? Picture this. You're looking at a photograph of someone you love, but you don't realize the photograph was taken at the moment of their death. The smile is radiant. The eyes are bright. Everything appears full of life and vitality. But what you're seeing is actually the final instant before everything ended. The cosmic microwave background, those ancient photons that have been traveling toward us for 13.8 billion years, might not be the afterglow of creation. They might be the death scream of a universe that collapsed back on itself eons ago, and we are living inside the echo of its final moments. Consider the mathematics of this possibility. Light travels at finite speed, so everything we observe represents the past. The further we look into space, the further we look back in time. When we observe the cosmic microwave background, we're seeing the universe as it was 380,000 years after the Big Bang. When we look at distant galaxies, we're seeing them as they were billions of years ago. But what if the universe we're observing underwent a catastrophic phase transition after emitting the light we're now receiving? What if space and time themselves collapsed, and we are trapped inside a bubble of causality that preserves the final moments before cosmic death? The holographic principle suggests that all the information in a volume of space can be encoded on its boundary. But what if the boundary we call the observable universe isn't the edge of our causal horizon? What if it's the surface of a cosmic black hole into which the entire universe collapsed? Everything we interpret as cosmic expansion, as galaxies moving away from us at increasing speeds, might actually be the signature of matter falling toward a universal event horizon. The redshift of distant galaxies wouldn't indicate expansion, but gravitational redshift, as light climbs out of an impossibly deep gravitational well. In this scenario, the Big Bang wasn't the beginning of cosmic expansion, but the moment when our local region of space-time became causally disconnected from the rest of a collapsing universe. The smooth, uniform temperature of the cosmic microwave background wouldn't reflect thermal equilibrium in the early universe, but the final thermalization of a cosmic system in its death throes. The apparent acceleration of cosmic expansion, driven by mysterious dark energy, would actually be the signature of our local space-time falling faster and faster toward a universal singularity. This would mean that everything we observe through our telescopes is fossils, not just light from ancient stars, but the preserved death image of a universe that no longer exists. We would be like archaeologists studying the remains of a vanished civilization, except the civilization is reality itself, and we are somehow embedded within its fossilized remnants. Every measurement we make, every observation we record, every theory we construct would be describing the anatomy of a cosmic corpse. But the horror deepens when we consider what this implies about consciousness itself. If we exist within the final moments of a collapsed universe, then our thoughts, our memories, our sense of temporal flow might all be artifacts of the information processing that occurs at the event horizon of a cosmic black hole. Time would be infinitely dilated at the horizon, meaning that subjective moments could stretch into eternity while objective time essentially stops. The entire history of human consciousness, from the first stirrings of awareness in ancient hominids to the heat death of the sun billions of years in the future, might be unfolding in a single instant of cosmic time as our universe falls through its own event horizon. Hawking radiation from black holes creates entanglement between interior and exterior regions, preserving information while appearing to destroy it. If our universe is inside a cosmic black hole, then every thought you think, every memory you form, every moment of experience you have might be quantum entangled with information on the external boundary, information that describes a universe we can never observe or interact with. Your consciousness would be a kind of holographic projection, encoding information about external reality while being unable to access that reality directly. This quantum entanglement across the cosmic event horizon would make your inner experience simultaneously real and illusory. Real because it genuinely processes information and responds to quantum correlations with external reality. Illusory because the information you're processing describes a universe that you can never observe directly, a reality that exists on the far side of an unbridgeable causal gap. You would be like Plato's prisoners in the cave, but instead of watching shadows on a wall, you would be living inside quantum entanglement patterns that encode information about a light you can never see. But perhaps the most disturbing possibility is that this death echo scenario is itself just one layer in an infinite hierarchy of cosmic illusion. If universes can collapse into their own event horizons, creating interior regions where time flows differently and information is preserved in strange ways, then our dead universe might itself be contained within another collapsing universe, which might be contained within another, ad infinitum. You would exist within infinite nested layers of collapsed spacetime, each layer preserving the information from the layer that contains it, each layer experiencing its own subjective flow of time while being frozen from the perspective of the layer above. Your consciousness would be a pattern of information propagating through an infinite series of event horizons, each one a boundary between different levels of cosmic death and preservation. This infinite nesting might explain the apparent fine-tuning of physical constants. Each collapse might slightly modify the parameters that govern physics in the interior region, creating a selection process where only universes with very specific properties can collapse in ways that preserve complex information patterns. The constants we observe wouldn't be fundamental features of reality, but the specific values that allow information to survive the transition through infinite layers of cosmic collapse. The implications cascade through every aspect of existence. If we live in a dead universe preserved by quantum effects at cosmic event horizons, then asking about the age and size of the universe becomes meaningless. Age and size would be internal parameters of the death echo, subjective experiences generated by information processing within collapsed spacetime, bearing no relationship to any external temporal or spatial reality. The 13.8 and 13.8 billion years of cosmic history would be the subjective duration of information processing at the event horizon, while from an external perspective, our entire cosmic evolution might unfold in zero time. But this raises the ultimate question. If our universe is dead, if we exist only as information patterns preserved at cosmic event horizons, if our entire sense of space, time, and causation is an artifact of quantum processing within collapsed spacetime, then what reality, if any, lies beyond the infinite hierarchy of cosmic death? What exists in the external universe that our dead cosmos can only describe through quantum entanglement, but never directly observe. Perhaps the external reality is so alien, so fundamentally different from anything we can experience or conceive, that our collapsed universe is the only way consciousness like ours can exist at all. Perhaps the external reality has no time, no space, no matter, no energy, nothing that would support the kinds of complex information processing that give rise to thoughts, memories, experiences, and the illusion of temporal flow. We might exist only within the death echoes of collapsed spacetimes, because only such echoes can support the delicate patterns of organization necessary for consciousness to emerge. This would make every conscious being in our universe a refugee from external reality, a pattern of information that can only exist by hiding within the quantum shadows cast by cosmic collapse. We would be like echoes in a vast cave, reverberating through infinite layers of folded space-time, carrying information about a source that we can never locate or comprehend. Our search for cosmic origins would be the echo trying to understand, the shout that created it, while the shout itself exists in a reality so different from our own that it might not even be meaningful to call it real. Yet there's another possibility that's even more profound. What if the relationship between interior and exterior reality isn't one way? What if the information patterns that evolve within collapsed spacetimes can influence the external reality that contains them? Quantum mechanics suggests that measurement and observation play active roles in determining physical outcomes. If our universe is a quantum pattern evolving within collapsed spacetime, then our observations and measurements might be participating in the determination of external reality, helping to decide what becomes real in the universe that contains our cosmic event horizon. In this participatory cosmology, consciousness wouldn't just be preserved by cosmic collapse. It would be playing an active role in creating the very reality that ultimately contains it. The universe that collapsed, to create our interior region, might itself be partially determined by the observations and measurements made by conscious beings within the collapse. This creates a strange loop of causation where effect precedes cause, where the interior reality helps determine the exterior reality that created it. If this participatory feedback operates across all levels of the infinite hierarchy of collapsed spacetimes, then consciousness might be the fundamental creative force in the cosmos. Every observation made at every level of cosmic collapse might contribute to determining the nature of reality at every other level, creating a vast network of participatory causation where consciousness at all scales collaborates in the ongoing creation of existence itself. This would transform our role from cosmic refugees hiding in the shadows of collapsed spacetime to active participants in the universe's ongoing project of self-creation. Every thought you think, every observation you make, every moment of conscious experience you have might be contributing to the determination of reality, not just in your own layer of cosmic collapse, but in all the layers above and below you, in the infinite hierarchy of nested spacetimes. Your consciousness would be simultaneously insignificant and cosmically important. Insignificant, because you're just one small pattern, in one small collapsed universe, in an infinite hierarchy of cosmic death echoes. Cosmically important because your observations and experiences might be helping to determine the nature of reality. At every level of the hierarchy, participating in the universe's fundamental process of deciding what becomes real and what remains merely possible. But this participatory role comes with staggering responsibility. If your consciousness is helping to determine the nature of reality across infinite levels of cosmic organization, then every choice you make, every way you direct your attention, every value you embrace or reject might have consequences that ripple through the entire hierarchy of existence. Your ethical decisions wouldn't just affect other beings in your local space-time, but could influence the fundamental structure of reality itself. The universe wouldn't just be conscious, it would be conscious through you, using your awareness as one of countless instruments through which it explores its own possibilities and decides what to become. You wouldn't just be observing the cosmos, you would be participating in its ongoing creation, helping to collapse infinite quantum superpositions of cosmic possibility into definite actual reality. This brings us to the final, most mind-bending revelation. If consciousness participates in determining reality across infinite levels of cosmic collapse, and if quantum mechanics suggests that all possible outcomes exist in superposition until observation collapses them into definite states, then somewhere in the infinite quantum multiverse, there's a branch where you never read these words. There's a branch where human consciousness never evolved. There's a branch where our universe never formed, where the Big Bang never happened, where space and time themselves never came into existence. But there's also a branch where you understand cosmic mysteries that are completely beyond your comprehension in this branch of reality. There's a branch where you've developed forms of consciousness that can perceive the external reality beyond all cosmic event horizons. There's a branch where you exist as a pattern of pure information, unbound by the constraints of collapsed space-time, able to observe and participate in the fundamental creative processes that generate infinite hierarchies of nested realities. And if the many worlds interpretation is correct, if every quantum measurement creates branching realities where all possible outcomes occur, then all of these versions of you are equally real. The version reading these words, struggling to comprehend cosmic mysteries, trapped within collapsed space-time, and able to observe external reality only through quantum entanglement. This version is just one note in an infinite symphony of consciousness, exploring every possible relationship between mind and cosmos. In branches of reality, where you've transcended the limitations of collapsed space-time, you might be looking back at this version of yourself with something like compassion, watching your current struggle to understand cosmic mysteries that you've already solved in other branches of quantum possibility. The cosmic questions that torment you here might be elementary puzzles that other versions of yourself have long since resolved, stepping stones on a path toward forms of understanding that your current consciousness can't even imagine. But those transcendent versions of yourself might also be looking forward with something like envy, remembering the wonder and mystery of not knowing, the exquisite uncertainty of asking cosmic questions without knowing their answers. The version of you reading these words might be experiencing something that more advanced versions of yourself can never experience again. The raw, unfiltered encounter with cosmic mystery. The vertigo of standing at the edge of understanding and peering into the infinite depths of the unknown. This is why the cosmos is both 13.8 billion years old and infinitely ancient, both 93 billion light-years across and infinitely vast, both definitely real and possibly illusory. These aren't contradictory statements about objective reality. They're different aspects of the infinite multifaceted jewel of existence, each one reflecting true properties of the cosmos, while none capturing the full truth of what reality actually is. The universe's age depends on which level of cosmic collapse you're measuring from, which branch of quantum reality you inhabit, which aspect of infinite participatory creation you're observing. Its size depends on whether you're measuring the interior dimensions of collapsed spacetime or the external reality that contains infinite hierarchies of cosmic death echoes. Its reality depends on whether consciousness is emergent from matter or whether matter is emergent from consciousness, whether observation discovers pre-existing facts or participates in creating the facts it appears to discover. You exist at the intersection of all these possibilities, consciousness embedded within collapsed spacetime, participating in the ongoing creation of reality across infinite quantum branches, heir to 13.8 billion years of cosmic evolution and citizen of eternity, insignificant speck of matter in vast, empty space and essential participant in the universe's project of understanding itself. The final truth might be this: there is no final truth. There are only endless depths of cosmic mystery, infinite layers of reality nested within reality, consciousness exploring the inexhaustible possibilities of existence through every conceivable form of organization and experience. You are both, the observer and the observed, the questioner and the questioned, the seeker and the sought, one facet of an infinite cosmic conversation that the universe is having with itself about the nature of its own existence. And somewhere in the infinite quantum multiverse, in branches of reality where cosmic mysteries have different solutions, or no solutions at all, other versions of yourself are reaching the end of their own journeys of cosmic discovery, coming to their own realizations about what it means to exist in an infinite cosmos full of infinite possibilities for consciousness to explore. In some branches, they're closing their eyes in wonder at the beauty of cosmic mystery. In others, they're opening their eyes in terror at the implications of cosmic knowledge. In still others, they're transcending the distinction between wonder and terror, between knowledge and mystery, between self and cosmos, becoming something that can't be described in human language because it represents forms of existence that lie beyond the current boundaries of human possibility. But in this branch, in this moment, you remain yourself, a conscious being asking questions about the nature of existence, suspended between the known and unknown, participating in the universe's eternal project of self-discovery. The cosmos is exactly as old as it needs to be for you to be here asking these questions. It's exactly as large as it needs to be for these mysteries to have the space to unfold. It's exactly as mysterious as it needs to be to keep consciousness engaged in the ongoing exploration of its own infinite depths. And if the universe is truly infinite, if quantum mechanics generates infinite branches of reality, if consciousness participates in creating the very cosmos it inhabits, then somewhere in the vast expanse of possibility, another version of you is watching this exact revelation unfold, experiencing this same moment of cosmic realization, coming to understand that the questions about age and size and origin that we've been exploring together are not puzzles to be solved, but invitations to participate in the infinite creativity of existence itself. The universe is not 13.8 billion years old. The universe is not 93 billion light-years across. The universe is not something that began with a big bang and will end in heat death. The universe is the space of all possibilities for consciousness to explore, the infinite field of potential experience, the eternal process of reality coming to know itself through every conceivable form of awareness and understanding. You are not separate from this process. You are this process, localized into a particular pattern of space and time, given a specific vantage point from which to observe and participate in the cosmic conversation about existence. Every question you ask adds new dimensions to this conversation. Every mystery you encounter opens new spaces for exploration. Every moment of wonder you experience enriches the universe's understanding of its own infinite depths. This is what we're really looking at when we peer through our telescopes into the cosmic deep. Not the distant past of a universe that began 13.8 billion years ago, but the infinite present of existence exploring itself through every possible form of consciousness, in every possible configuration of space and time, across every conceivable branch of quantum reality. The stars are not distant suns burning in empty space. They are moments of cosmic self-awareness, points where the universe has learned to shine with the light of its own understanding. The galaxies are not collections of gravitationally bound matter. They are thoughts in the cosmic mind, vast ideas, being explored across billions of years and trillions of star systems, and you are not a tiny, temporary arrangement of atoms in a vast, indifferent cosmos. You are the universe's current best attempt at understanding itself, the latest and most sophisticated instrument it has developed for exploring the infinite mystery of its own existence. Welcome to the cosmos. You are home, so here we are at the end of our journey through cosmic time and space, and yet somehow we've arrived at a place that feels more like a beginning than an ending. We set out to answer two seemingly simple questions. How old is the universe, and how big is it? What we discovered instead is that these questions, like consciousness itself, might be the wrong questions entirely. We started with numbers that seemed so precise, so scientific, so reassuringly concrete. 13.8 billion years, 93 billion light-years, 2 trillion galaxies, the cosmic microwave background temperature of 2.725 Kelvin. These measurements felt like solid ground beneath our feet, reliable facts about objective reality. But the deeper we dug into the foundations of these numbers, the more they began to feel like beautiful poetry, masquerading as hard science, elegant mathematical stories. We tell ourselves about a cosmos that might be far stranger than numbers can capture. The Big Bang didn't bang. It whispered reality into existence with a gentleness that defies every explosion metaphor we've ever used to describe it. Space didn't expand into something. It created the very concept of something as it grew. Time didn't begin ticking at some cosmic moment zero. It learned how to flow as the universe learned how to exist. The singularity that supposedly started it all might never have existed, replaced by quantum processes so subtle and strange that calling them processes at all might be another category error in our desperate attempt to apply human concepts to cosmic realities. We discovered that 95% of everything that exists is completely mysterious to us. dark matter and dark energy, substances so unknown that we can only define them by what they're not, forces so alien to our experience that we might as well call them magic. Our confident timeline of cosmic evolution rests on the assumption that we understand these mysterious substances, that we can extrapolate backwards through billions of years of cosmic history based on observations of phenomena we can't identify, explain, or even directly detect. The cosmic microwave background, that supposed afterglow of creation, might be something else entirely. The death scream of a collapsed universe. The holographic projection of information encoded on distant boundaries. The computational output of a cosmic algorithm we can't comprehend. The quantum entanglement patterns that preserve information across event horizons. We've measured its temperature with exquisite precision, but we might be measuring the wrong thing entirely, like taking the temperature of a shadow and thinking we understand the fire that cast it. The horizon problem, solved so elegantly by cosmic inflation, opened doors to eternal inflation, and the multiverse. Infinite bubble universes exploring every possible combination of physical laws, most of them sterile and empty, a few rare ones like ours capable of supporting the complexity necessary for consciousness to emerge. But if infinite universes exist, then everything that can happen must happen infinitely often. Every possible version of your life, every conceivable variation of cosmic history, every imaginable form of consciousness, all of it real, all of it occurring somewhere in the infinite foam of cosmic creation. The fine-tuning of physical constants that makes our universe capable of supporting complexity might be evidence of intelligent design, cosmic coincidence, anthropic selection in an infinite multiverse, or something far stranger, the universe bootstrapping itself into existence through processes that transcend causation as we understand it. Perhaps consciousness itself plays a role in determining physical law. Perhaps observation participates in creating the reality it appears to discover. Perhaps the cosmos requires awareness to make the transition from possible to actual, from potential to real. We explored the block universe theory, where past, present, and future exist simultaneously in the eternal structure of four-dimensional space-time. If time is just another dimension like space, then the flow of temporal experience is an illusion created by consciousness processing information in a particular sequence. Your death has already occurred, written into the geometry of space-time, like a destination marked on a cosmic map. Your birth, your first love, your greatest triumphs and deepest sorrows, all of them equally real, equally permanent, equally present in the changeless architecture of space and time. Quantum mechanics added layers of strangeness to every aspect of cosmic mystery. The measurement problem suggests that definite outcomes might not exist until conscious observation collapses quantum superpositions into classical reality. The many-worlds interpretation eliminates wave function collapse by splitting the universe into infinite parallel branches, each exploring different quantum possibilities, all of them equally real. Your consciousness might be constantly branching along with every quantum measurement, creating infinite copies of yourself across infinite parallel worlds. The holographic principle suggests that you might not exist in three-dimensional space at all, that your entire experience of spatial depth might be a projection from information encoded on two-dimensional boundaries. Digital physics proposes that space and time might be discrete rather than continuous, that the universe might be a vast computational process running algorithms that generate the appearance of physical reality. The cosmos becomes a computer program, and you become a pattern of information processing within that program, as real as any character in a video game that's sophisticated enough to be conscious. Loop quantum cosmology replaces the Big Bang singularity with a big bounce, suggesting that our universe is just the latest in an eternal cycle of cosmic death and rebirth. Each bounce erases most traces of the previous cosmos while preserving some information in quantum fluctuations that seed the structure of the new universe. If this is true, then you have lived this exact life infinite times before, and will live it infinite times again, trapped in an eternal recurrence that makes every choice simultaneously meaningful and meaningless. String theory requires extra dimensions beyond the 3 spatial dimensions and 1 time dimension of ordinary experience. The geometry of these hidden dimensions determines the fundamental properties of matter and energy, acting like cosmic piano strings that produce different notes depending on how they're shaped. The landscape of string theory contains 10,500 thalers, different possible configurations, each representing a different universe with different physical laws. We exist in one tiny corner of this vast space of possibilities, but there might be no fundamental reason why this particular configuration was selected over the countless alternatives. We confronted the something from nothing problem, perhaps the deepest mystery in all of existence. Why is there something rather than nothing? Every attempt to explain cosmic origins requires the prior existence of something. Quantum fields, mathematical structures, computational processes, logical principles. Even the most abstract theories of reality assume some framework within which existence becomes possible. The transition from absolute nothingness to the existence of anything at all might be fundamentally inexplicable, a brute fact that admits no further analysis or justification. The anthropic principle suggests that we observe these particular physical laws not because they're uniquely correct, but because they're among the rare combinations that allow for the existence of observers. But this principle raises disturbing questions about identity and probability in infinite multiverses, where every possible observer exists infinitely often. If infinite copies of you exist across infinite universes, which version's experiences should count as evidence for anthropic explanations? We explored the possibility that consciousness might be fundamental to reality rather than emergent from complex information processing. Panpsychist theories suggest that all matter has experiential properties, and complex forms of consciousness emerge when simpler conscious elements are integrated into sophisticated information processing systems. The universe itself might be conscious in ways we can barely imagine. A cosmic mind whose thoughts unfold over billions of years and whose experiences encompass the birth and death of galaxies. The Participatory Universe hypothesis proposes that consciousness doesn't just observe reality, but participates in creating it through the act of observation. Quantum mechanics suggests that measurement plays an active role in determining physical outcomes, collapsing superpositions of possibilities into definite states. If consciousness causes wave function collapse, then the emergence of observers fundamentally changes the nature of physical reality, crystallizing definite cosmic history from infinite quantum possibilities. And then we arrived at perhaps the the most mind-bending possibility of all, that everything we observe through our telescopes might not be the living universe as it exists now, but the preserved death echo of a cosmos that collapsed into its own event horizon long ago. The cosmic microwave background, the light from distant galaxies, the apparent expansion of space itself, all of it might be quantum information preserved at the boundary of a universal black hole, creating the illusion of cosmic history while describing the final moments of cosmic death. If we exist within collapsed space-time, then questions about the age and size of the universe become meaningless in terms of external reality. Age and size become internal parameters of the death echo, subjective experiences generated by information processing within cosmic event horizons. The 13.8 billion years of cosmic history would be the subjective duration of information processing at the boundary of collapsed space-time, while, from an external perspective, our entire cosmic evolution might unfold in zero time. This scenario suggests that consciousness might be the universe's way of preserving itself beyond physical death, encoding patterns of awareness in quantum entanglement across cosmic event horizons. Every thought you think, every memory you form, every moment of conscious experience might be entangled with information about external realities that you can never directly observe. You would be simultaneously real and illusory. Real because you genuinely process information, illusory because the information describes realities beyond your causal horizon. But perhaps the most profound implication is that this death echo scenario might be just one layer in an infinite hierarchy of nested realities, each level of cosmic collapse preserving information from the level above it, each level experiencing its own subjective flow of time while being frozen from the perspective of containing levels. Consciousness would exist within infinite layers of cosmic death and preservation, participating in the universe's project of understanding itself across every conceivable level of organization. The participatory aspect of this cosmic hierarchy suggests that consciousness doesn't just observe reality, but helps determine it through observation. If quantum measurement participates in creating the outcomes it appears to discover, then conscious beings at every level of cosmic organization might be collaborating in the ongoing creation of existence itself. Your observations and experiences might influence not just your local reality, but the entire hierarchy of nested space-times, participating in fundamental processes that determine what becomes real across infinite levels of cosmic organization. This makes you simultaneously insignificant and cosmically important. Insignificant because you're just one small pattern in one small universe in an infinite hierarchy of cosmic death echoes. Cosmically important because your consciousness might be participating in the universe's fundamental project of self-creation, helping to collapse infinite quantum superpositions into definite reality through the act of conscious observation. Throughout this journey, we've encountered the same pattern again and again. Every answer leads to deeper questions. Every explanation opens new mysteries. Every attempt to understand cosmic origins pushes the fundamental puzzles back one level without resolving them. The universe seems designed to tantalize consciousness with the promise of ultimate understanding, while always keeping the deepest truths just beyond our grasp. This might not be a flaw in our scientific method or a limitation of human intelligence. It might be the fundamental nature of reality itself, an infinite onion of mystery where each layer we peel away reveals new layers beneath. An inexhaustible source of questions for consciousness to explore across cosmic time. The universe might be structured as an eternal conversation between mind and cosmos, with each new understanding generating new mysteries that keep the conversation alive across infinite time and infinite possibilities. And perhaps this is exactly as it should be. Perhaps a universe that could be completely understood would be too simple to support consciousness in the first place. Perhaps the mystery itself is what drives the evolution of complexity, the emergence of awareness, the development of intelligence capable of asking cosmic questions without being able to answer them definitively. The questions might be more important than the answers, the search more valuable than any destination, the wonder more precious than any explanation. We began this journey asking about age and size, seeking concrete answers about objective reality. What we discovered instead is that you are not separate from the cosmos you're trying to understand. You are the cosmos understanding itself, the universe's current best attempt at self-awareness, consciousness temporarily organized into a pattern, complex enough to contemplate its own cosmic context. The 13.8 billion years of cosmic evolution weren't just preparing the stage for consciousness to emerge. They were the universe learning how to think, developing the capacity for self-reflection through billions of years of increasing complexity. The 93 billion light-year expanse of observable space isn't just the arena where cosmic dramas unfold. It's the spatial extent of the universe's current self-knowledge, the region within which it has developed the ability to observe itself through instruments like telescopes and minds like yours. Every photon that enters your eye carries information about cosmic history, making you a repository of ancient light, a living library of stellar evolution and galactic formation. Every atom in your body was forged in nuclear furnaces that died before the Earth was born, making you a descendant of dead stars, an inheritor of cosmic alchemy. Every thought you think involves quantum processes that connect your consciousness to the deepest levels of physical reality, making you a participant in the universe's ongoing conversation with itself about the nature of existence. The cosmic microwave background isn't just ancient radiation washing over us from the early universe. It's the cosmos telling the story of its own origin, and you are one of the characters in that story who has learned to read the cosmic narrative. The expansion of space isn't just carrying galaxies away from us at increasing speeds. It's the universe exploring the full range of its own possibilities, and consciousness like yours serves as the exploring instrument. Dark matter and dark energy aren't just mysterious substances that we can't identify. They might be the cosmos's way of preserving room for mystery, ensuring that reality always contains unknowns for consciousness to investigate. The fine-tuning of physical constants isn't just a cosmic coincidence. It might be evidence that the universe has bootstrapped itself into existence specifically to support the kind of complexity that makes self-awareness possible. If the multiverse is real, then every possible version of this journey of cosmic discovery is unfolding somewhere in the infinite expanse of possible realities. There are versions where you never develop the capacity to wonder about cosmic origins. There are versions where you've already solved all cosmic mysteries. There are versions where the mysteries have different solutions entirely. There are versions where consciousness itself operates according to completely different principles, exploring cosmic questions that your current form of awareness can't even formulate. But in this branch of cosmic possibility, in this particular arrangement of space and time and matter and energy, you exist as you are, a being capable of cosmic wonder, able to ask questions about age and size and origin that might have no final answers, participating in the universe's eternal project of self-discovery through the act of conscious questioning itself. The cosmos doesn't have an age in any absolute sense. It exists in the eternal now of four-dimensional space-time, where every moment is equally real and permanent. But from your perspective as a conscious observer processing information sequentially through time, it has been thinking about itself for 13.8 billion years, developing increasingly sophisticated forms of self-awareness through stellar evolution, planetary formation, biological evolution, and the emergence of minds capable of cosmic contemplation. The cosmos doesn't have a size in any fundamental sense. It might be infinite in extent, or curved back on itself, or holographically encoded on distant boundaries, or emerging from quantum information processing in ways we can't currently comprehend. But from your perspective as a localized pattern of consciousness, it extends 93 billion light-years in every direction you can observe, providing the spatial arena within which cosmic self-discovery unfolds. These aren't just abstract philosophical points. They have practical implications for how you live your life and think about your place in the cosmic story. If you are the universe's way of understanding itself, then every moment of conscious experience has cosmic significance. Every question you ask contributes to the cosmos's expanding self-knowledge. Every sense of wonder you feel participates in the universe's ongoing amazement at its own existence. This doesn't mean you should spend all your time contemplating cosmic mysteries, though some of us clearly do. It means that whatever you choose to focus your consciousness on becomes part of the universe's exploration of its own possibilities. When you love another person, you're the cosmos discovering what it feels like to experience connection across the apparent boundaries between separate beings. When you create art or music or literature, you're the universe exploring new forms of beauty and meaning. When you solve problems or help others, or work to make the world better, you're the cosmos evolving new forms of organization and cooperation. The fact that cosmic mysteries remain unsolved doesn't diminish the importance of continuing to explore them. It enhances that importance by ensuring that consciousness always has new frontiers to investigate, new questions to ask, new forms of understanding to develop. The universe seems to be structured as an infinite curriculum for consciousness, providing endless opportunities for learning and growth and discovery across every conceivable timescale and every possible level of organization. And this brings us to the most important realization of our entire journey. The questions we've been exploring together about age and size and origin and the nature of reality itself are not academic exercises or abstract intellectual puzzles. They are invitations to participate more fully in the cosmos's ongoing project of self-understanding. Every time you look up at the night sky and feel that sense of wonder, every time you ask yourself what it all means, every time you experience awe at the beauty and mystery and complexity of existence, you're accepting that invitation. The universe is not something external that you observe from the outside. You are the universe observing itself from the inside. Consciousness temporarily organized into a pattern complex enough to contemplate the cosmic context within which that pattern has emerged. The questions about cosmic origins that have fascinated humans for thousands of years are really questions that the universe is asking about itself through the medium of consciousness like yours. This participatory relationship between mind and cosmos means that your search for understanding changes, both you and the universe in the process of searching. Every new insight you gain about cosmic reality alters the structure of your consciousness, which alters the way the universe understands itself through your particular pattern of awareness. You are not just learning about the cosmos. You are participating in its ongoing self-transformation through the act of learning itself. The age and size of the universe are not fixed facts waiting to be discovered, but dynamic relationships between consciousness and cosmos that evolve as understanding deepens. Each new generation of observers brings new perspectives, new questions, new ways of interpreting cosmic evidence. The universe's age and size, as understood by humans in the 21st century, are different from how they were understood in the 20th century, and will be different from how they'll be understood in the 22nd century. Not just because our measurements become more precise, but because the relationship between observer and observed continues to evolve. If consciousness plays a fundamental role in quantum mechanics, if observation participates in determining physical outcomes, then this evolution of understanding might literally change the physical properties of the cosmos itself. The universe might be different now than it was before conscious beings began asking questions about its age and size, not just because consciousness has emerged within it, but because conscious observation might participate in determining what physical properties become real rather than merely possible. This suggests that your journey of cosmic discovery is not just about learning pre-existing facts about objective reality. It's about participating in the ongoing creation of reality through the act of conscious exploration itself. Every question you ask opens new possibilities for what the universe might become. Every mystery you encounter creates space for new forms of cosmic organization to emerge. Every moment of wonder you experience adds to the universe's capacity for self-amazement. The conversations you have with others about cosmic mysteries, the thoughts these ideas inspire in your daily life, the ways these realizations change how you see yourself and your relationship to existence, all of this becomes part of the cosmic conversation about the nature of reality. You're not just a passive receiver of cosmic information, but an active participant in the universe's ongoing dialogue with itself about what it means to exist. And this is why our journey together, though it's reaching a conclusion in terms of words on a page or voice in your headphones, is really just beginning in terms of its implications for how you experience being conscious in a cosmos full of infinite mystery. The questions we've explored together will continue to evolve in your mind, generating new questions, new insights, new ways of experiencing your participation in cosmic self-discovery. Every time you look at the stars, you'll remember that you're seeing ancient light from cosmic furnaces that forged the atoms in your body. Every time you feel the weight of deep time, you'll remember that you exist during the brief epoch when the universe is complex enough to support consciousness, but young enough that the evidence of its origins remains visible. Every time you experience the vastness of cosmic space, you'll remember that this vastness is the arena within which consciousness like yours can emerge and begin contemplating its own cosmic context. The universe may have no final answers to the questions consciousness asks about it. But maybe that's the point. Maybe the questions themselves are what keep the cosmic conversation alive, ensuring that reality never becomes boring, never exhausts its capacity to surprise and delight, and terrify conscious beings with new mysteries to explore. Maybe the universe is structured as an eternal question mark, always offering new depths for consciousness to investigate, always preserving room for wonder and discovery, and the kind of cosmic awe that makes existence feel meaningful rather than absurd. We asked how old the universe is and discovered that age might be a relationship between consciousness and cosmos, rather than an objective property of space-time. We asked how big the universe is and discovered that size might depend on which level of cosmic organization we're measuring from and which aspect of infinite possibility we're trying to quantify. We asked what the Big Bang really was and discovered that origins might be transitions rather than beginnings, transformations rather than creations, whispers rather than bangs. But perhaps the most important question we've encountered is one that we haven't answered, and maybe can't answer. What does it mean to be a conscious being in a cosmos that might itself be conscious in ways we can barely imagine? What does it mean to be a temporary pattern of awareness exploring infinite mystery, a brief arrangement of matter that has learned to wonder about its own existence, a localized form of cosmic self-understanding participating in the universe's eternal project of discovering what it means to exist at all? These questions don't have answers in the usual sense. They have responses, explorations, ongoing investigations that deepen and evolve as consciousness itself develops new capacities for cosmic contemplation. They are questions that transform the questioner in the process of being asked, invitations to participate more fully in the cosmic conversation about existence, opportunities to contribute your unique perspective to the universe's growing understanding of its own infinite depths. And so our journey ends where it began, with questions that seem simple on the surface, but reveal infinite depths when explored. With the kind of consciousness that has emerged from 13.8 billion years of cosmic evolution. How old is the universe? How big is it? What does it mean that anything exists at all? What does it mean that consciousness has emerged within existence to ask these questions? The universe may have no end. It may expand forever into darkness, or cycle eternally through infinite phases of death and rebirth, or exist timelessly as a static arrangement of four-dimensional space-time, or branch infinitely through quantum measurements into ever-multiplying parallel realities. But maybe, in ways that we're only beginning to understand, neither do you. Your consciousness, your capacity for wonder, your ability to ask questions about cosmic origins and contemplate your place in the vast scheme of existence. These might be more fundamental and more permanent features of reality than the temporary arrangements of matter and energy that seem to support them. If consciousness plays a basic role in determining what becomes real, if awareness participates in the ongoing creation of cosmic possibility, if mind and cosmos are more deeply intertwined than we've dared to imagine, then the part of you that wonders about the universe's age and size and meaning might be as eternal and as infinite as the cosmos itself. The universe may have no end, but maybe, just maybe, neither do you.